Loading, just some minutes.
Mhm.
Yeah, it doesn't seem to be live yet. Ah, now it is.
It is?
Good.
Perfect.
Perfect. Thanks a lot, Suru. Okay, maybe we can start. Welcome everyone to this workshop on scalable development of low-code artifacts. My name is Juan de Lara. I work at the Universidad Autónoma of Madrid in Spain, and I would like to welcome you, all of you, on behalf of the Locomote project. Right. So just a few words of introduction. Of course, you all know what's low-code, but just in case, quoting Wikipedia. A low-code development platform is a software that provides a development environment used to create application software through graphical user interfaces and configuration instead of traditional hand-coded computer programming. And so this way of development had an impact. And actually, in 2016, Gartner predicted that by this year, 2020, at least 50% of all new business applications will be created with high productivity toolsets. And they also forecasted an increase for companies developing low-code platforms to over 21 billion over the next 4 years. I mean, by 2020 again. So if you look at the ecosystem of low-code development platforms, you find many proposals from big players like Google, Amazon, Microsoft, and so on, but many others, mainly OutSystem, Salesforce, and many more of them. You name. Um, so we look more in details what are the typical features of low-code environments. We can see that most of them are based on the cloud. And the reason is because this simplifies many things. It simplifies both development, configuration, but also deployment for execution is just on the cloud. Also because many of these environments are targeted to citizen developers. So these are developers that are not really professionals, but they want to have applications quickly for their business. And so they don't use general or programming languages like Java, but they normally use graphical languages, forms, configurations, and so on. And of course, if you are like me, you have a background on software engineering and on model-driven engineering, you realize that actually low-code shares many objectives and ideas with model-driven engineering, right? In NDE, we want to really create automation solutions for creating software with more productivity, right? And typically we do so using sometimes using domain-specific languages, either graphical or textual. But even there are many similarities, there are also some differences too. So many ND solutions, they are not really cloud-based. They are, for example, based on Eclipse, for using desktop applications. And also some ND solutions, they don't target end users, they target developers or engineers, especially within the Eclipse ecosystem. But we will see also today that very interestingly, Eclipse and other IDEs are also moving to the cloud. So we'll see some synergies here. All right. After this brief introduction, a few words about the Locomote project for those of you that are not familiar with it. Locomote project is an European Union project. It's actually an innovative training network from the Marie Curie program. It started in 2019. We last for 4 years, and we are 14 partners across Europe, 5 academic and 9 industrial. So the main goal of this project is basically training researchers, 50 of them, on enabling technologies to create low-code platforms. And the technologies that we focus are basically model-driven engineering, mostly, but also cloud computing and machine learning. And in addition to produce PhDs, PhD theses, so the idea is also to have to create a common platform and to develop components for an ecosystem that will allow to create low-code engineering platforms. And also the focus will be on scalability, so that these components will scale to create and model large applications. And actually, scalability will be the topic of today's workshop. So the idea is to have a look at techniques and technologies that will allow developing low-code platforms supporting scalable modeling of applications. So we will see today that we have a very exciting program where we will see a lot of methods and techniques and building blocks that we will be able to use to develop such platforms. And we will also see examples of current low-code platforms. So we have an exciting lineup of speakers from industry like Typefox, Clipboard, Eclipse Source, Axelians, and Newground, and also academia. We will have a speaker from the University of Linz in Austria, IMT Atlantique in France, and the University of Montreal in Canada. This is the agenda. You have the agenda on the web here. We will have 2 sessions in the morning where you will see all presentations will be 40 minutes. So the idea is to have more or less 30 minutes for the presentation itself, and then 10 minutes for questions. We will have at 11, we plan to have a break. We will not cut the transmission, so you can stay here, well, either grab a coffee and cookies, or stay here and have more extended and informal discussion. Then we will have a slot for discussions at the end of the morning session, and we will have a lunch break if you are watching from Europe. And then in the afternoon, we will have the 3 talks, and we will finish with a slot of discussion and wrap up. I would encourage you to have an active participation and to ask every question that you would like to ask. If you are in this Zoom session, please use the Zoom chat, or even better, use your mic. If you are watching through YouTube, please use the YouTube chat. And you can also use Twitter using the Locomote hashtag. All right, so I think we can move forward to the first speaker, Jan Conlane, and that will talk about text-first DSLs in the cloud. So I will pass the mic to him.
Thanks a lot. Can you hear me?
Yes, we do.
Very good. Thanks a lot, Juan, for that introduction. My name is, oops, that's not the first slide, this one. My name is Jan Köhnlein. I work for Typefox and for Gitpod. And I'm going to present you text-first DSLs in the cloud today with the tool stack that we are using in our customer projects. And, oh, wait, I have to set up my Zoom correctly, such that I can see what I show. This is a bit better. Okay. All right. At Typefox, we've been building domain-specific languages and modeling tools for more than a decade. And this is our current tool stack. We are still on the text-first level for very good reasons. I'm also going to point out it within this talk. So for some reason, cannot. Oh, strange. So this is the goal. We are going to build a textual domain-specific language with a rich text editor. Rich means that we have content assist, syntax highlighting, and all this stuff. Because for domain-specific languages, you cannot really expect people to know how your language works. So they need a lot of help from the UI to get towards working models. We are implementing a small code generator because, I mean, that's the whole point in the modeling stuff. In the end, you want to execute your code and your models, but models don't execute. You have to convert them to code. So we write a code generator, and we will add diagram support because, yeah, I mean, this is a low-code workshop, so we have to at least cover it, graphics. But it's a very special way we do that, and I'm curious how you will anticipate that approach. We will embed the entire thing in a VS Code extension. Well, that's not actually cloud, you would say. Why VS Code extension? Well, first of all, if you really want your DSL to reach a very big audience, you should use for the #1 IDE, and that's currently VS Code, at least according to some studies. But on the other hand, VS Code extensions are also the way that we package up language servers today and can reuse them in Eclipse Theia. And Eclipse Theia is the new cloud-based IDE framework in Eclipse. And it's the basis of all the cool new technologies like Gitpod and Shay. Bless you. Why text first? Yeah, we've been experimenting a lot with graphics and text and stuff like that. And text has a few real benefits towards graphics. First of all, it's really fast to edit. So with a keyboard, you will always be faster than with your mouse or touchpad or whatever tool you use to build your graphical models. You will have very fast turnarounds. You will always see the entire model. There are no hidden details. So my experience, I have been in a lot of migration projects where we, for example, started with some UML models and then had to, transfer them into a more specific DSL. And in these models, there were always like ghost objects. So things that remnants from refactorings that didn't work and all that stuff. So there was a lot of garbage actually in these models that were just never shown because the tools didn't show them. So you won't have that with text in that way. One of the biggest benefits of text towards graphics is you can reuse your standard tools. And if you're really a developer, you are used to Git, diffing, merging. You can use a standard text editor if your models get entirely broken and so on. You can store, version, merge your models easily without having to think about additional abstraction and GUI. And text has a higher resilience to errors. That means, well, in essence, it's not a high resilience because we easily get syntax errors, but they're very easy to fix, even outside of your current modeling tool. The cons are text is not really low code. So we're in a low code workshop here. It is code, but if you build DSLs, you usually raise the level of abstraction to a very high level. So that is actually the game. So you will maybe not really catch the non-programmers with a text first approach, but still it's very interesting why we do that, because we also think it scales a lot better than graphics. And yeah, the other disadvantage of text is that sometimes you get lost in the details because it's linear. Usually you don't use folding or hiding details and stuff like that. So you will have a hard time getting an overview on a bigger model that is spread across several files. But that can be mitigated by just adding graphical views on top of it. So this is a very maybe confusing slide about how we use our current technologies, this tool stack. So as I said, we are going to build a VS Code extension. That's the whole thing, will be packaged up in a VS Code extension, and that has different parts. So now I'd really love to have a mouse pointer, but I can't somehow get one. Okay. So a VS Code extension has some kind of configuration part written in JSON. That's on the top left. A manifest, editor configuration, and so on. And then it usually has some kind of code for activation and deactivation of that extension. And Then we are going to build a language server. A language server is something that it's actually an invention of Microsoft VS Code. It's their internal API, how they hook in the smartness or the specificity to a specific language into a very generic text editor. And that is a protocol that even allows to implement the language server in a completely different language than the rest of the system. And then another specialty of VS Code is if you want to have additional views, things like that, that are not text-based, you have to create a web view. And that is another separate application that is embedded in your browser-based application and communicates with the rest through a very thin interface. So let's have a short look how a VS Code extension configuration part looks like. The core of it is an extension manifest. A VS Code extension is an NPM package. So if you're not into JavaScript development, NPM is like, if you're coming from Java, it's like the Maven of JavaScript. So there is a big repository with reusable components that you can just refer to, and then it will be automatically downloaded to your system, to your development environment when you need them. And apart from some meta information like name and so on, publisher, this one, the NPM package manifest for a VS Code extension also can contain contributions, and these contributions are languages. So you see the contributes languages and the states language that we're going to use as an example here, an example for state machines. And it can also provide grammars, which is for syntax highlighting, which is completely client-side in VS Code. Client-side means in the editor and not on the language server. Yeah, so that's basically it. The last line is main pack states extension. That is, where the entry point for the extension is when it is being loaded. Syntax highlighting is client-side. Maybe I don't get too much into the details here. VS Code extensions usually use the text-made grammar syntax that is based on regular expressions, and a lot of rules are matched and then mapped to some style constants that are internally, again, mapped via the themes and so on to like font styles and colors and things like that. Okay, the language server protocol is actually a pretty cool thing because VS Code offers this very generic text editor that you can hook in the smartness of a language. And it's a protocol, as I already said, so you can implement this smartness in any language you like. Why is that? The reason for that is that the implementation you need to feed these services, like give me content assist at a specific place or follow this link, is usually, so the calculation is usually the same that you would do in a compiler. So language server, you can look at the language server as an extended compiler that has several hooks within the compilation process, gives you access to, for example, the symbol table of your language in order to follow links. And compilers are usually written in the language that they compile. So it's a good idea to have a separation here as a protocol and not just as an API. But how would you write a language server? It sounds like a lot of work. And this is where Xtext comes to our help. Xtext is an Eclipse open source framework. And it's been around for quite a while now. Very mature. It scales like hell. So you can really build very big models as long as you separate them in various files. And it has an incremental code generation mechanism and so on. So it's really mature and good. And the key point on an Xtext is you start with a grammar that looks pretty much like an enhanced Backus-Naur form grammar with a few additions. And from that grammar, Xtext can generate a language server. And that language server will then be hooked into the extension and serve the text editor in VS Code or Thea or whatever you use as a client. So this is the entire grammar for this little state machine example here. You see we have keywords, like state machine, state, and event. These are the strings. And then we have calls to other rules, like the ID rules. We have assignments. That means if that rule matches, the returning value should be assigned to a feature in the AST model, like name equals or states plus equals. And one specialty is in the last line of this grammar. Xtext also allows you to define cross-references. So a transition refers to an event and it refers to a state. And these event and state are not defined here at this place, but they're defined elsewhere and just cross-referenced from that specific thing. And that cross-reference syntax, from that, you can derive a lot of tooling, like follow links, rename refactoring, and so on. So as we have this cross-reference semantics already in the grammar, this really opens up for a lot of automation in this language server generation process. Okay, to execute your DSL, you usually write a code generator. I hope you can read that. It's a bit light. This is an example. We usually write these code generators in extend. This language has been derived by us as well, but it's a bit out of fashion. But it's still the best language I know for code generation because it has certain very nifty features. For example, it makes a difference between white space and gray space. So gray space is white space you just have because you're writing a template, and white space is what really goes into the output. So there's a very sophisticated mechanism to manage this kind of thing. But what you basically see here, you have an entry point, do generate, you get a resource. So Xtext actually creates an EMF model from your text files that are stored in the resource. And then you traverse the resource, and for whatever element you encounter, like state machine, you call to Java code or generate code and spit out some text. So this is basically how code generation works. Okay, let me give you a demo. So this is VS Code. Oh, I'm already too far. This is VS Code. You see, oops, that's a bit too big. So you see this a DSL. You see we have syntax highlighting already in place. You also see that the parser that's generated from the grammar is already there because syntax errors are immediately marked like this. Okay, what should it be? And it's also integrated here. So that all that smartness comes from the language server, as well as this highlighting, or when I control click, I follow to the definition of a cross-reference, and yeah, all that stuff. Even that I can rename this state to something. And you see it hasn't only changed this one, but also this one, because it's aware of cross-references and will automatically update cross-references as well. So this is really, really nice. Just from that, little grammar we written, you get this very, very rich editor support. Oh, I forgot to mention the content assist, which may be the most important thing. So content assist for keywords here, event and state, but also for cross-references that match this location you are at in the text. Okay, so much for this demo. Okay, somehow I have a small technical problem. Let me stop. Wait. Can do it here. All right, can you still hear me?
Yes, we do.
Oh, okay, yes. Good. Yeah, just my headphone just disconnected for a second. Okay, so that's all nice. Oops. But in the end, we want to have graphics as well. So graphics, in this case, know them from UML. And they are graphical in the sense that they focus a lot of interconnections between elements and not so much about details and definitions on the individual elements. So it's much about transitions and not so much about the properties of states. If you want to build a graphical view or editor in VS Code, you have to use a web view. And a web view is, I mean, a VS Code extension is VS Code application is basically a web application running in Electron. So this is really a browser that you see here that browses a web application. And in that web DOM, there will be an iframe, and that is what shows your web view. And that web view runs in this iframe a completely separate application. So it's like the language server. You have a third service, a third like microservice that serves the diagram and has to communicate with the rest of the extension via a JSON-based API. So it can exchange JSON messages with the extension. All right, we have to decide for a graphical framework, and we use Sprotty. Sprotty is also an Eclipse framework. It's a web-based. It has a reactive architecture, and that was the main reason to build it. Reactive means it uses a virtual DOM technology, which is very popular by, you may know that from React or Angular. All these use virtual DOMs because actually updating the document object model, the DOM of a web application, is very expensive. What we do there is you create a shadow model of that, and you just make the minimum patches to the real DOM because it's so expensive. As far as I know, we are the first who did that for graphics. But that's also the reason why we're using SVG, which is part of the DOM and not so much a Canvas API for rendering. The other speciality is that we have you see the circle on the right-hand side, we have a unidirectional flow of events. That means even if the user does an action, creates an action on the viewer, this action is transformed to action dispatcher, and by that, maybe transformed into a command or sent to the outside and then executed on the command stack and then going back to the model. This is always the same direction, always the same flow of events. If you compare that, for example, with GMF, where they have like 3 models, they try to reconcile and try to enable you to make changes on the diagram model or the view model or the semantic model at the same time and then update everything else. This is very confusing and leads to a lot of errors in practice. But here we have a single flow of information, so it's always clear how events make their way through the application's components. And the third real sweet spot of Sprotty is it has a client-server application, as these components really communicate stuff via actions, and actions are like the events in Sprotty, but they're just JSON structures, JSON objects, and serializable. These actions can come from the viewer, but they can also come from an external source, and they can also be processed by an external source. And that opens up the entire architecture for a client-server mode, where the authoritative model really is located at a server, and that server can communicate via Sprotty actions with the Sprotty client that's running in a browser. And that's exactly what we're going to use. Sprotty has comes with a couple of adapters. Well, first of all, there's the Sprotty main thing for the diagram client code. Then there's an adapter for Xtext, which makes it very easy to generate Sprotty diagrams from Xtext DSLs. And then there's Sprotty VS Code to glue these Sprotty diagrams into a VS Code-based application. Sprotty uses a diagram model internally. We call that the S model, S for Sprotty, of course. And I mean, if you're into diagramming, this shouldn't be much of a surprise. We have a graph, and the graph contains nodes and edges, and nodes create ports and compartments and labels, and edges can also have labels. Actually, this is not hard baked into Sprotty. That's the default. You could use any kind of other model as well. Maybe if you're looking for timing diagrams or scatter plots or whatever. But for most applications that we target, they are nodes and edges, and this is a good default. The Sprotty model is completely serializable, and cross-references are established via IDs. So every element has an ID, and if it refers to another element, like an edge has a source and a target, this cross-reference is made via the ID of the source and target. A Sprotty application, so a client, a diagram client, mainly consists of a dependency injection configuration. You see here that you can bind some services like the logger, or even override some parts of the structure of this client, like the model factory. But it's also the place where you map these S model elements that I showed you on the previous slides to actual views. And views are like the figures, okay? They are basically functions that take in an S model element and spit out an SVG element. And in this example, you see that we configure elements that have the ID, the type graph, and they come in as an S graph, so as an S model element S graph, and they are being transferred to an S graph view. In addition to that mapping, you can also enable and disable some features on these model elements. That is a little bit like if you're into GEF or Eclipse modeling, it's like the edit policies. So it's a composite pattern of adding behavior to your figures in the diagram client. All right, so now we have a diagram config, and we have a language server. How do we wire the entire thing up? So first of all, the language server now has to provide us with a Sprotty model that can be then rendered in the client. And that is achieved via a diagram generator. So this is very similar to the code generator that you've seen before. And I'll show you that in a second. This slide is basically about this functionality. So on the right-hand side, you see the Sprotty client with the reactive cycle. And now we hook in, we plug in the language server from the other side. And that language server has some extensions to accept or dispatch actions, so Sprotty events. That means our language server needs two more messages to send actions in either direction. All that is already implemented for you in Sprotty Xtext, so that comes for free. And the other cool thing is, you've seen that this when I changed something in the demo, in the textual model, there's a certain life cycle associated with the editor changes. So immediately the new model gets parsed, and errors are shown, and things like that. And that in that exact life cycle, the diagram generator hooks into as well. Okay, so this is basically the diagram generator. It takes our AST model from Xtext when it changes and converts it into an S graph, so an Sprotty model. Okay, and this is how it's hooked up. It's maybe a bit too detailed at the moment. So in order to wire up the rest, so now we have this, we have extended the language server with the diagram generator. We added the language, extended the language server protocol in order to exchange actions. And now we have to connect the missing pieces. And this is done with Sprotty VS Code. And Sprotty VS Code basically allows you to, well, it manages the different web views. So if you reopen the same diagram, you don't get a new web view, but the one that you already have. And it also does the communication. The communication works a bit like that. So imagine in the language server, so the text editor gets some change. The text editor change gets propagated to the language server. The language server reparses the new text and then triggers the diagram generator. That one creates a new Sprotty model. That one is created, is packed up into an action, Sprotty action. That Sprotty action is transported via LSP or LSP extension to the extension code on the VS Code side, to the language client. That one, here we have an action message. So it should be forwarded to the right web view, to the corresponding web view. And that one gets the action message. It extracts the action and feeds it into its reactive cycle. So how does it look like? So this is the very same example. I can open this in a diagram. And then you see whenever I make a change here, like add a new state, oops. This change is propagated to the diagram. So this change is propagated to the language server. The language server creates a new S model with a new node and propagates that to the client, and that renders it. And now when I connect that thing, so I have to mention an event and then connect it to this one. Okay, you see the diagram is updated. That's another special thing about Sprotty. When you update the diagram, the changes are automatically animated. So if you're into graphical tooling, I would strongly suggest to have a look at animations, but because these make it much easier for a user to actually grasp what the model change actually is. Okay, so this is a nice diagram. This is also synchronized. That also comes by default. Whenever I click on a node, the respective text gets selected. Whenever I click on the text, the respective node gets selected. But there is more to it, and that's the last thing I want to show you. You may want to edit that stuff. So edit on the diagram level. How would you achieve that? So of course, you could now go the GMF or most diagram frameworks approach and say, okay, I'm here. So I want to change this name. Then I change the label name and then propagate that to the language server. And that one has to kind of figure out what a label change should be in the text model. And what we actually do here, we don't perform these model changes on the AST model, but we try to map them to language server protocol, to textual actions. So when I double click on that label, what actually happens is the same as if I trigger a rename refactoring on that state node. So rename this symbol. Okay. And that makes sure that my event flow is always text first. That means the text will have the ultimate truth, the authoritative state. And whenever I want to change my model, I have to do it via text changes. And the language server protocol gives me already some abstractions over these text changes, like rename refactoring. So I change the name here to foo new, and you see it's updated. The same holds for adding new elements. So if I add a new state here, what actually happens is it calls this kind of code template for a new state. Oh, where is it? Somehow it's not shown. So you should see a light bulb here. Where is it? for some reason doesn't show up. So we have installed some code templates which allow you to create, like, scaffold certain elements in text. And that exact same thing is triggered when I just do when I use this pop-up menu to create a new state. Oh, let me show here. So, all right. And well, for this, for the reconnection, there's a little bit more to do. So you have to add some language to a new action on the language server. So this is not as straightforward as the other operations that I just shown you, but it also can be done on the textual level. One last thing I want to highlight now is, all right, so in this diagram, you see everything, but you actually don't see everything. So that is the typical difference between text and graphical editing, because the events that we have up here, they don't have a direct correspondence in the diagram. They're just referred to as labels from the edges. So when I add a new event here, I can do that. And you see it's added here at the end of the text, but it doesn't have a graphical representation. So it doesn't end up anywhere in the diagram. And this is very typical. Usually a lot of information on graphics is hidden in property panels, in additional trees that may show which events are there, and so on. So a diagram is almost never showing you the entire truth, but it should be made for humans to read, because it's much easier to follow the references in this diagram than it is to follow references in text. So keep that in mind when you build your tools, that not everything will have a representation in a diagram, and you have to make sure not to produce garbage that no one really notices. Okay, I guess I'm almost at the end of my time. No, I really am. So I have a few more slides here. I can upload the slides after this talk on the development process, which is a bit more demanding than usually, because you're kind of developing 3 applications as one: the extension, the language server, and the web view. And yeah, that's all. The entire example is also wrapped up here in this GitHub repository. And maybe as a last action, oopsie, sorry, that was too fast. I will show you the entire thing in the web. I just have shown you that in VS Code so far, so locally. This is the repository of this example. I can, on GitHub, I can use this Git pod. This is our brand new workspace provisioning and IDE framework product in the cloud. So this will open on our infrastructure. We'll create a container that will run Thea, the Eclipse IDE that's web-based, and we'll start it on this repository, download this repository, and make it possible to work on that. Unfortunately, I'm in a, yeah, it should come up soon. So this is really my browser. I hope it's starting soon. It looks like yeah, here we go. So here you see the same example. It takes a while until the extension gets loaded. Now syntax highlighting has popped in, and now I can open this in a diagram. And you will see exactly the same stuff that I showed you on VS Code, because it's exactly the same extension. So it can just be reused as is in Thea, and by being usable in Thea, it can also be reused in Git pod. All right, that's all I wanted to show you. Thanks a lot for your attention. And if there are some questions, I think I have a few minutes to answer them.
Cool. Thank you. Thanks a lot, Jan. Any question you would like to ask? Please feel free to use your mic, or if you are watching on YouTube, you can use the YouTube chat or even Twitter. So maybe I can, in the meantime, I can start. So yeah, it was a extremely nice demo. Yeah, I have one question. It's more of a conceptual thing, no? So you have shown text first DSL. So I think the rationale is very clear. So sometimes it's much faster to write text, and it also has an advantage. It's more scalable than graphics, right? Even if you have mentioned that in your graphical view you can skip some details, right? So my question is, what happens when the text program, the DSL, is very large? So the graphics would be very large as well. Is there any way in Sprotty or in your approach to, I don't know, to separate into more than one view, or to do some kind of abstraction that you can handle, so that you can handle big diagrams?
Yes. So that's basically two questions. How is the scalability of the entire thing? And let me start with the textual part. As for diagrams, we should always keep in mind that we are dealing with humans. So humans don't like text files that are 2 gigabytes length. And so what you usually do is split it up into multiple files. Xtext is very scalable in the sense that it does incremental code generation. So it looks at changes and what parts of the model are affected, and only updates this incrementally. And that also holds for the updates of the diagram. So if I just change a little thing in one part of the model and that doesn't affect a lot of diagrams, all these unaffected diagrams are not touched. The other thing is in terms of representation graphically. So does that scale? Does Sprotty deal with big models? Yes, there is a new feature that a colleague of mine, Miro, who is also leading the Sprotty project, recently built that made it possible to even render the floor plan of a chip, so of a microchip, which is pretty big. It has lots of connections and components with Sprotty. And it's a combination of a level of detail approach and clipping. So not rendering things that are not in the current viewport, and also not showing all details of all elements when the zoom level doesn't make sense to show it.
Thank you. I think we have a question from the YouTube chat, from Jesus Sanchez Cuadrado. He asked, is it possible to integrate the editor in an external website?
Yes, that's possible. The editor, the textual editor is basically Monaco from VS Code. We just kind of copied that over to Thea. It's open source, so that is completely legal. And that has the hooks for the language server protocol as well. In fact, we did another project to separate that out. That was called Monaco Language Client. You can have a look at that. In the meantime, we abandoned that because that enabled to plug in the language server directly into the Monaco editor. But now that we support VS Code extensions, we rather do that with the original Monaco stuff and the language server client that is provided by the VS Code extension host.
Yeah, because as a follow-up of this question, I noticed that when you use Xtext, you can target JavaScript libraries like ACE or code mirrors, things like that. So is it something additional that you did to support all this, or
yeah, there's also Xtext support for ACE and code mirror, and I'm not sure what state that is. I haven't used that for a while. I know that Item is also doing some kind of web-based stuff based on Xtext, so you might want to have a look at that as well.
All right. We have another question from the YouTube chat by Sasha Nison. Can I manually lay out the diagram, or is it always auto layout? If I can, where are the coordinates stored?
Okay, in this example, I showed you coordinates are not stored because we're using automatic layout, and for reasons of simplicity, yeah, you basically have two options to store the coordinates. Either you add another model, like many frameworks do, where you store just identifiers of the elements and their coordinates, or you could also persist the Sprotty model for that. Or you just store, if you want to have a single source of truth, you can store the coordinates, of course, in the DSL itself. So, I mean, you're free to add comments, for example, or annotations, or even make them first-class citizens in the DSL as well. That's all possible. We built that for customers.
Right. Okay, then we have questions also from participants in this Zoom meeting. So Arcel has a question, so maybe you can ask the question using your mic. Please, Arcel.
Well, I have a question. This is Luca speaking, Luca Blardinelli. My question is possible to, I mean, the change propagation is also only possible from text to diagrams, or also the opposite is possible?
Yeah, that's what I mean with the unidirectional flow of events. So you should make sure that you have one model that rules everything, that has the absolute truth. If you do a text-based approach like here in Xtext, it should be the text. So all changes you make should be executed on the text first. That means each user interaction you do in our approach should be mapped to a text operation, and then this text operation is propagated to the diagram again. So what I've shown you is when I double click on a label, it calls a rename refactoring on the text for the specific element at that location. And that one is then executed, and then the change is propagated. And that way we make sure to also cover all the cross references and things like that. So we completely rely on the text to work.
Hello, can you hear me?
Yes.
Yeah. My name is Arsene. Thank you for the good presentation. I'm wondering, I'm used on when someone is creating a language such as Python, the way you structure it, the way you do it. What's the big differences between when you're creating language such as Python or JavaScript, and when you're creating a low-code platform such as the one you use for this?
Well, the main difference is that these DSLs are usually much smaller, and they're not built to solve every problem in the world, but specific to domain. For example, in this case, it was states. It's a very technical domain, but we also have, customers from all kinds of industries that have, where the domain elements are controllers, microcontrollers, or share bank financial things, assurance contracts, and so on. So you could really capture the knowledge of the domain in that language with the means of the language. That is the main point of DSLs. If you're doing general purpose language, you may want to have it, Turing complete, so it should be able to solve all the problems that are out there, and that's the most that's a difference. So DSLs are usually a bit leaner and don't have that richness in expressions or computability, but that's just a rule of thumb. It's not a necessity.
But that means you still have to do the lexers and the parsers,
Exactly. Xtext helps you to do that. We also did general purpose languages with Xtext, like Extend, for example, the one that we use for the code generator is completely written with Xtext. So that scales also to bigger and more complicated languages. But of course, it requires a bit more work.
Yeah, thank you.
Okay, any other comment or question?
Yes, I have a question. I'm Alessandro. Well, currently I'm working in an Xtext grammar with Eclipse in EMF, and I had to override some class, some generated class. Then I had to make some tests, and I also thinking and writing a formatter and a custom validator. How could I do that things with VS?
Okay. So the question is there Xtext support for VS Code? It's a good question. So there is very basic support for Xtext and also for Extend in VS Code. VS Code also has a Java language server. So most of that should be possible, but it's not very convenient. What we actually do is we generate these, I mean, it's a separate application anyway. So we currently still use Eclipse to develop the DSL and the language server, but then hook it into VS Code and develop the extension part in VS Code and the Sprotty part as well. We can also do that in Gitpod because Thea also supports a lot of that, but with the same limitations. So Xtext is not really ready for web-based development, developing Xtext. But we are working on that. So we are thinking about changing that a bit, maybe extending the language server, maybe building a new kind of simpler Xtext that is based on web technologies and that could be better integrated tooling-wise into the development process.
Thank you very much.
All right, any other comments? We are a little bit out of time, but we have, we have Slack at the end, so there should be no problem. Comments or questions? All right, if not, then thanks a lot, Jan. It was an excellent talk. Thank you very much.
Thank you
for all the insights you provided. And so let's move to the next presentation, which is web-based modeling tools with EMF.cloud, and it will be given by Philipp Langer from Eclipse Source.
Thank you very much. I will just start sharing my screen. Desktop 1, so share.
Yeah, we see your screen.
You see it? Okay, perfect. All right. Hi, everyone. My name is Philipp Langer. I work with Eclipse Source in Austria, Vienna. And Eclipse Source is a service and technology provider for open source technologies in the Eclipse ecosystem. And I myself, I'm mostly specialized on web-based domain-specific modeling tools, and also on building domain-specific graphical models. And that's what I want to focus on today. So first of all, I would like to thank Jan for his presentation, because it did a very good groundwork for what we are talking about today, because we are building on top of the technologies that we've just seen. Oh, sorry, I think I accidentally muted myself, sorry. So let's start. Basically, what you all know that in the last, I don't know, 10 or 12 years, the Eclipse modeling framework and the Eclipse Rich Client platform is a very, very nice technology ecosystem that allows us to build domain-specific modeling tools. And with that, I mean tools that not only cover diagrams, but also textual models, table-based UIs, and even form-based UIs. So you see examples of those tools here. However, also as Jan mentioned, in the recent years, more and more the requirements arose that those tools are not only built on top of rich client applications, but also on top of web-based technologies. And there are mainly two reasons for that. Web-based technologies like web-based UIs like HTML5 and CSS and SVG, they offer quite a lot of flexibility in terms of how you can implement user interfaces and make them look very modern and smooth. And also in terms of rendering speed, they have certain advantages in some cases, especially when it comes to SVG, for instance. Also, they sort of detach or they remove the constraints that you have when you integrate that UI in a certain application. because if they are HTML based, they can be not only integrated in rich client applications like Eclipse or in Visual Studio Code, but also they can be executed in the browser, which means that you can deploy your web application, your applications in the cloud and just access them using a browser without any installation. So those are the reasons why web-based modeling tools also became more and more trendy and also useful. The question now is, of course, how can we still use all the greatness that we mentioned before when building web-based modeling tools, when building modeling tools based on Eclipse and EMF, now when we want to do the same based on web-based technologies like Thea, Chromium, and VS Code. Basically, there are already a couple of technologies that we can actually use to do that today, and Jan also showed already a few of them in his talk. So he covered, for instance, the textual languages that can be just as before used in a web-based context. Also, he has shown Sprotty, which is covering a part of the diagram area. And there are also other frameworks like JSON Forms, which can help you to build form-based modeling tools or UIs for modeling tools that can also, in some way or another, hook up with a modeling platform that runs on the server. However, what we would like to achieve with EMF Cloud is to make it more simple to hook up those, I would say, modeling tool front ends to modeling backends that actually run the Eclipse modeling framework, so that there's less effort to build such tools, comparable to how less effort it is, or how few effort it is to build it today in Eclipse Rich Client. Have more standard components around that you can use, and also encode the best practices that you typically apply when building such modeling tools. So that's basically the overall goal of the Eclipse project called emf.cloud. So really the goal is to provide a common home, sort of like an umbrella for components that facilitate or simplify the usage of EMF and its ecosystem, and help those components to incubate towards becoming standard components that you would use when building such tools, and that encapsulate the best practices, some of which also Jan already mentioned in his previous talk, like the reactive unidirectional active action cycle. So EMF Cloud is currently an Eclipse incubation project. It has been, I think, founded 1.5 years ago, and has since then grown in number of components it hosts and provides. And it has a pretty large scope, as you can imagine, when you want to facilitate using EMF in web-based and cloud-based modeling tools. It has quite a large scope, ranging from middleware for making EMF models accessible to clients, which, for instance, also could involve adapters so that you can use or access EMF models via JSON and not only via XMI, which makes it easier in some cases when you hook up TypeScript-based clients, for instance, provide editing support and all that stuff. So there's a couple of components, the big scope, and already a couple of components. Since this talk is too short to cover all components that are currently available in EMF Cloud, I will focus mostly on two of those components, one of which is the EMF model server, and the second one is the Eclipse GLSP, Graphical Language Server platform, which is essentially covering this use case where you have also diagrams that are not hooked up with a language server, textual language server, as Jan showed before, but really are hooked up with arbitrary EMF modeling backends. Right, there is quite a lot of things, so I will directly jump to the more technical slides and explain why we need those model server also in combination with GLSP. But I just want to mention, if you're interested, there is also a couple of other components. Like in EMF Cloud, we have also eCore tooling, so you can build eCore models in Thea or VS Code. There is also generic UI components like a tree model editor, where you have like a tree on the left-hand side, and depending on your selection, you get a form on the right-hand side to edit the model details, very similar to the generic EMF editor that you may know from Eclipse. And last but not least, is alongside other components, there is an EMF JSON mapper based on Jackson, which allows you to load any EMF model in JSON and basically work with it the same way as you would work with it in XMI, but have JSON as the primary serialization format. Right. With that, I would like to jump to the first component that I would like to cover, which is the EMF model server. So first of all, the question is why we would use such a model server. So as mentioned before, our goal is to build web-based modeling tools that have all the great modern UI front ends in VS Code or in Thea, but still can use EMF on the server to benefit from all the greatness in the ecosystem that is available. Of course, you can use most of those technologies that come from EMF, like model management, serialization, commands, command stack, and all this stuff, because EMF has no dependency on a certain UI technology, and you can just do the same as you would do inside of Eclipse in rich client application, but do it on the server. However, this does not cover all the use cases that you would actually have in a typical modeling tool, because if you look at as an example like this one, we have here a web-based modeling tool where we have a form-based editor with a tree master detail UI here. Then we have textual editor here and a graphical editor, for instance. And very typically, they all operate on a shared, quite large model. And parts of, for instance, this form-based editor would represent the part of the model highlighted here, and the graphical one an overlapping part, which is highlighted here, and so on and so forth. And now that's all no problem yet, but if you want to start modifying one editor, you would of course like to get these other editors updated as soon as you make a change. And to apply the architecture, the modern architecture also that Jan mentioned before, we would like to employ on the server certain services that process those models so that they are optimized for the use for the respective representation. So for instance, for text-based languages, as Jan mentioned, for instance, we have the language server protocol, which is a perfect fit. So it sort of like encapsulates all the manipulation of text and the understanding of the language, and only provides to the editor what is really needed for the UI in order to provide good editing experience. And the same idea should be applied to all of these other editors, so that there are always services representation specific that fuel those editors with the respective know-how. So they encapsulate a little bit the know-how and also encapsulate the entire model. So of course, when we now want to synchronize those editors, since they operate on an overlapping part of the model potentially, they would have to be aware of each other, these services, but that's obviously not a very good architecture. This wouldn't scale if you have not 3, but like 10 of those services running. So we really don't want them to talk to each other, but still we want them to be synchronized when it comes to the model source. And this is exactly where the model server component comes into play. So it's really just a component that allows to synchronize a model instance across multiple services that require access to this model in order to provide certain editing capabilities. And I can also show this application in demo, in action, just a demo how this would look like. Let me just switch to this application and maximize it here. So we can, in this application, it's really just an example application that demonstrates how you can build such a modeling tool. So there is a diagram editor that I can open. There is a form-based editor that I can open alongside it. And then there is a textual DSL editor that I can also open. And as you can see here, those are all different types of editors, but they share the same, they talk to the same model in the back. So for instance, when I now add a new task here, we see that here this new task has been added as well. And when I change the name, for instance, we see that this name has also been changed here, and vice versa, of course. When I rename it here again, then the diagram will also update and show immediately what the respective label of this element is. And last but not least, here in this textual editor, which is based on Xtext, you have all the language support that we have seen already in the previous talk, but you can also access for instance, to refer to tasks of this joint model. And you can see here that it also is aware already of this new task that I've just created with the name text123 and so on. So basically, all these editors have certain services that provide the editing capabilities for the respective front ends, and those services talk to the same model server instance so that they can share a joint model. Let's have a look at how this is actually implemented. Basically, the model server is just a Java-based server based on Javelin, which is quite a nice REST framework. And the goal is to provide also the dirty state and the common command change interface to multiple services, so that you only need to load a model once and then can share the dirty state across all the services. So it's a little bit, if you're in Eclipse terminology, it's a little bit like a shared editing domain, and nothing more than that. So it purposefully is just focusing on this task. So it does not provide any model repository capabilities or versioning or anything like that. You can hook it up with existing technologies to the model server itself, but it doesn't try to solve all the problems, but really just focus on this one. In order to achieve that, it provides a REST API, as mentioned before, with the typical operations, and provides the model in multiple formats depending on the client what they prefer, either JSON or XML. And there is a client library for Java and JavaScript, so that it's very easy to hook up to this model server. So just to give you a very rough example how this may look like, in order to load a model in the Java API, you would just instantiate a new model server for a certain URL, and then you can request URIs, model URIs, and once they are loaded, you can process them in some way. And that's essentially what all these services that represent, for instance, the diagram editor capabilities, as well as the textual editing, what they do is they obtain a certain model in the format that they would like. And with that, when they don't specify an additional flag, they all load the same instance in one session. Now you can subscribe via socket to changes. And also patch models using this model server. So for instance, you this editor can send with a very simple JSON format commands basically to this server, where you can specify, for instance, that here we have a command with the type add, and we add a new object value here at the index 1, for instance. And this this service would then send this to the server, this command. The server would perform it if it can. If it can't, then it would just reject and let the client know. But if it can, it would perform the actual model change and would then notify all listeners again, so that they can synchronize and react to it. And that's exactly what we have seen here before in the when I showed that I renamed a certain element in the diagram, that the text that the the tree editor would be aware of it and could react to this change in some way. Yeah, so that's basically the model server that is provided in EMF Cloud. And just to give you also more context, let's have a look at how this then can be connected to a service, like in this case, the example GLSP. So GLSP is short for Graphical Language Server Platform. And really the idea of that is that it applies the architectural pattern of the language server protocol for text, but to graphical modeling in order to achieve the same goals and characteristics that we all find very useful in the language server protocol. And that is that it allows to build web-based diagram clients independently of how the client technology is created, or is what the client technology is. It allows you to encapsulate the language know-how on the server, so that you don't have to encode the language server, very much on the client, so that you can basically replace it more easily and have really a front end or a client that can really focus only on rendering and user interaction. The Graphical Language Server Platform, or GLSP, is also an Eclipse project. It is more or less part of the EMF Cloud ecosystem, but technically it already incubated into an own project, since there was a lot of interest in using it in different use cases, and we wanted to have it as an own project in the meantime. So it's there also since 1.5 years at Eclipse, and is really focusing on this providing diagram editors. And it can be, just as mentioned here, it can be hooked up to the model server, but also to arbitrary other model sources. So let's have a look at GLSP, how the separation of concern between client and server is currently set up. So basically, when you look at a typical editor, diagram editor, there are a couple of capabilities typically encapsulated or implemented in such an editor, ranging from diagram editing, editing tools, visual feedback, which already show certain editing rules, whether you are allowed to add an element, for instance, in this context, or to rename or create an edge between model elements in another context, and so on. Commands to really apply changes, and so on, edit transactions, live validations, and all this stuff. So there's a lot of capabilities. In order to draw the line in GLSP, we specified that everything that needs to be on the client and to provide good usability in terms of fast feedback and rendering runs on the client, which is then rendering, editing tools, and visual feedback. And everything else runs only on the server. So this is what really encapsulates the language know-how, like editing rules through to model management. Of course, certain elements on the client need to be aware of certain parts from the language know-how. So for instance, the visual feedback needs to be aware about certain aspects of the editing rules to, for instance, show the user directly whether an operation can be applied in a certain context or not. And for that, there is this protocol that sort of parameterizes the client, so that the client can already show, for instance, that you cannot rename an element in this case for this value, for instance, and reject the change in a nice, graceful way. For building such diagram editors with diagram servers, the GLSP project provides basically 4 components. It's on the one hand side a Java-based standalone server implementation, then of course the protocol, the client framework, which is then providing the actual diagram editing and visual feedback, server communication, and so on. And last but not least, the IDE or tool platform integrations, so you can integrate GLSP editors in Thea, VS Code, or in Eclipse. It's based on quite cool technologies. So the Java-based server, for instance, is based on LSP4j, which is an Eclipse project to build language servers, actually, but it has a generic base to build any JSON RPC servers. And it is heavily built on especially the diagram, or only the diagram client framework is built on Sprotty, which Jan showed in the previous talk, which we use for rendering and also for the model transfer between client and server. So just to give you an idea of how this actually looks like in practice when you open a diagram, so the client would request a language server for a specific URI, for instance. The server would then the language server would then load from an arbitrary model source, can be a model server as mentioned before, but can be an arbitrary model source, an EMF model, or also JSON, whatever you like, and translate this into the S model that Jan mentioned before, which would then be sent back to the client. And then based on Sprotty, this S model would then be rendered, which means translated into SVG and then rendered in the browser. So once the user would then like to apply certain operations, the client does not know, since it doesn't have any language know-how per se, does not know which operations can actually be applied. So the client requests, for instance, a number of things, for instance, the tool palette actions, context menus, editing capabilities, and so on from the server. And depending on the request, it would then render certain UI elements, like it would render a tool palette and so on, which shows all the things that can be, for instance, added in this context. Once then the client would trigger such a tool palette action, for instance, for creating a node, the client is not aware of what this actually means, but it would just send the create node action with the specific type ID and some context information like location to the server. And then the server can actually process this action by invoking a handler that would then manipulate the original model source and then regenerate the graph, just like in the first step where we translated the model source into a graph. Again, to update the model, send this to the client, which can then re-render the diagram. So this scheme is also exactly as already mentioned, sort of like a unidirectional action or event circle. So whenever there is an action coming in, we don't change the diagram directly, but we modify the model source and then regenerate the diagram, which has a lot of advantages when it comes to making it basically more simple to manage the different states of diagram, model, coordinates information, and all the stuff that you have. And it allows more easily also to share those changes with other services that might be hooked up to the EMF model server. So I don't have too much time to go into too much code. I just wanted to mention that there is 2 examples online that you can look at, which serve 2 different means. So on the one hand side, there is this minimal example, which you see down here. So it's really just an editor that allows you to draw rectangles. And here is the relevant code that is shown to implement that. So it's really not a lot. You have the client-side rendering specification or configuration that also Jan mentioned. So it's exactly basic pure Sprotty code. It only specifies how certain element types or diagram types map to certain views. And on the right-hand side, you see the corresponding server module configuration, which is based on dependency injection, where you can configure the diagram, for instance, with things like which element types even exist in this diagram. So they correspond then to this node and graph here on the left-hand side. And you can configure operation handlers, like here, this minimal create node operation handler, which is sort of an operation handler to create a node. And this is exactly what is then automatically shown here on the left-hand side in the palette. And the last thing you minimally need to specify is where does the original model actually come from. So that's basically the specification of what the model source is. And this is here in the simplest form, a JSON file that you can just read and translate into a diagram. The second example is the workflow example, which I will demo also, which is a more sophisticated example showing all the different capabilities of GLSP. So from direct editing, validation, and contextual editing with auto-completion and all this stuff, copy-paste. So it shows all the different features that you can actually do. Of course, then the code is not as simple as this anymore, but I can show you later how the code then roughly looks like. And I hope that it's still quite manageable, even though there are a number of capabilities being implemented. Last but not least, and that's the last thing I want to mention before the demo. Of course, a diagram editor is fine, but typically for building modeling tools, you want to integrate those in tool platforms so that you can combine those editors with other capabilities of the tool. So GLSP allows you to integrate GLSP editors in Eclipse Thea, VS Code, and also even in rich client Eclipse applications. So let me just show you how that looks like. I will show you now different examples of exactly the same diagram server in the back, but different front ends. So first of all, let's start with here the Eclipse rich client application. So when I double click this element, this WF file, you see here this workflow example that I've mentioned before. So you can basically, as you would expect, you can create elements, you can connect them with edges, you can move them, zoom in, zoom out, you can even change, for instance, the labels and so on. And you can also for instance, navigate to other files inside this same IDE. So for instance, here with this push task, there is some example that we've just built so that you can navigate to the documentation. And what this would then do, it would open a second text editor where search for the push heading and would directly jump to it. So that you can really integrate diagrams with other editors very nicely in Eclipse, but also, of course, in other editors. Right, the same can also be opened, of course, in VS Code. So let me just now switch to VS Code. It's the same language server again, and you can here right-click on Open Workflow Example. So we see it's exactly the same functionality. You can again create those different types of elements and connect them with each other and even change here the labels and so on and so forth. Of course, this is also integrated with platform capabilities like theming. So when you, for instance, change here the color theme, then the diagram would update according to the preferences of the language theme, for instance. And last but not least, this is integrated also with Eclipse Thea. So now I'm opening a browser that points to an Eclipse Thea instance. And here again, I can open the diagram editor exactly the same and do all the same changes as mentioned before. Just because I didn't show it before, a few capabilities that Thea and GLSP can do. So for instance, you can do, let me just create a decision note here. You can do validation. So when you run the validation is obviously run on the server and just markers are then sent down to the client. And these markers are then of course also integrated with the Thea platform so that they also show up in the central problems view. Of course, when you click on them, you would then jump through the elements. You have undo redo support. So I'm now hitting Control Z, Control Shift Z to show you that. And there is also some additional sophisticated features like, first of all, of course, you have label edit validation, but there is also this contextual editing support where you can, for instance, open here a direct editor task, and then it would allow you to do certain actions in a more efficient way, where it has auto-completion and, of course, also validation. So if you do something wrong, it would show it directly. And all this stuff is, again, handled actually on the server, interpreted, and then sent down to the client, and may then lead, for instance, to a change of the model. So I can here specify 35, and then this model change would actually be applied. Right, let me just go back to the slides to see if I forgot to mention integrations that we have. Yeah, so I think I've shown keyboard shortcuts, integration with other views and editors, navigation across diagrams and other editors, as mentioned before, problem markers. Yeah, and sure, of course, copy paste is also supported. So for instance, when I now click on these, I select now these 3 elements, hit Control C, and then I hit Control V, and then we see that we got those again, and I can add them as often as I like. Of course, here is the most interesting part of that is not that copy paste is actually working, but how all these features are implemented. Since we want to encapsulate the language know-how on the server, all these things involve the server in some way or another. Just to give you an example, navigation across editors. So when you resolve an element against the model, for instance, then of course there is a navigation action that will be sent to the server so that the server can actually resolve against some query against the model, and would then just send down to the client to which graphical element we should navigate. Problem markers, for instance, the validation of obviously runs on the server and would just send down the problem markers. And for copy paste, on copy, the client would ask the server, what is the information that you would like to put into the clipboard? This would be then sent down to the client. The client actually puts it into the clipboard, and on paste, the client would again send the clipboard content to the server so that you can do more sophisticated stuff. And many of you probably know that copy paste in diagrams is not such an easy thing to implement. So it's good that we have that integrated on the server. Right. Last but not least, I think I'm not sure how much time I still have left, but I just wanted to mention a few other cool things that are going on in GLSP, but also in the broader EMF Cloud ecosystem. So on the one hand side, there is quite a nice commercial FBD editor being developed by a company which builds on top of GLSP and also other technologies in the EMF Cloud ecosystem. So you see here, you can build quite sophisticated, nice looking diagrams, which are then integrated with also property views, as well as with other textual languages that you may reference from your diagrams and vice versa. Here is a screenshot also of the eCore support in Eclipse Thea. So you see here that there is also an eCore diagram editor with property views, just as the one that you're used to inside of Eclipse. And last but not least, what I find also pretty cool is that there has been a project where the GLSP editors have been integrated with the debug adapter protocol to allow debugging diagrams essentially. So you can, using the generic debug UI in Thea or in VS Code, jump through your diagrams, and the editor would always highlight the element where you're currently in. It allows you to add breakpoints. It can show you the variables or the scope where you're currently in, and you can navigate into or step over and do all these typical debug operations. Right. With that, a few conclusions. So first of all, as you have seen, we are using Eclipse Sprotty as a rendering technology on the client, and we are very, very happy with that. It's extremely flexible, and it makes it very easy to provide very modern-looking diagrams, which can then, based on GLSP, also be hooked up to EMF-based model servers or diagram servers to provide editors. We feel in the last projects that we did in the last couple of years or 1 or 2 years that EMF Cloud unlocks a very high reuse on the server. So if you have existing EMF-based tools, it's actually quite nice to migrate them to a web-based front end without having to rewrite everything from scratch. So there's actually a little bit of refactoring typically in the beginning of those projects to separate the UI from the model management and the language know-how, but then it's quite straightforward to actually migrate in an incremental way your Eclipse-based modeling tool to cloud-based IDE or to Thea or to VS Code. We are very, very happy with the modular language server-oriented architecture because it's extremely versatile. So you can combine arbitrarily the different services like a textual language server with graphical language server platform, with the model server, without the model server, whether it reads the information that the model from a database or from a file. So this is very modular, and you can basically configure it exactly the way you like to do, which is very, very flexible in my opinion. And last but not least, I think this is also showing very well that building a diagram editor, for instance, with GLSP does not imply any tool platform lock-ins. So you can still choose whether you essentially want to target in the end Thea, VS Code, or even Eclipse Rich Client, or all of them at the same time. And I think this is very future-proof because it opens up platform migration very easily in the future because there is no one-size-fits-all platform. I'm sure you will be addressing different platforms in the future. As Jan said, VS Code is very popular now. 5 years ago, it was maybe IntelliJ. So it's changing a lot, and you don't want to re-implement everything again and again, especially when it comes to the language know-how. Right. If you have any questions, feel free to ask me now or also contact me. So my email address is here. And please also make sure to check out our project pages at Eclipse and on GitHub. And we have also there chat support, forums, and all this stuff. And we are looking forward to learn more about your use cases and questions. Thanks.
Thanks a lot, Philip, for the excellent presentation. Do we have any questions that you would like to ask? Well, maybe I can start. So I was wondering, maybe you have mentioned that and I have missed it, but I kept wondering, how do you specify the graphical concrete syntax of the visual language that you are rendering and so on? Do you use some DSL of your own? Do you use something like Sirius, or do you do it programmatically?
No, it's all programmatically, and as I mentioned, the separation of concerns is really that the client is responsible for rendering, and that's basically it. And for that, we are using Sprotty. So basically, what Sprotty does is you have this S-graph, which I think I have sketched here, which consists of nodes and edges and labels and compartments and all this stuff, and each of them have a type. And you map those types in this configuration to view elements. And each view element is essentially reading this diagram element and translates it into SVG. So it's essentially what you do is you specify SVG to implement the rendering. That's for simple nodes where you, for instance, have only a rectangle with lines and so on and so forth. Of course, you can make compartments to nest them within each other. Then it gets a little bit more complex. So again, you have SVG for each of those components, but then you may have to apply layouters so that the inner structure of a diagram element is then layouted, for instance, with a flow layout, box layout, and so on and so forth.
Cool.
But yeah, we find this, it depends really, of course, as always, on the use case. So if you have a DSL or like in Sirius, some sort of diagram model where you specify it, it's great for prototyping. You're very fast at a certain step, but at the same time, it also adds a layer on top of the whole rendering, right? So you need to sort of understand what this model means and how this interpreter would then actually render the model. And with Sprotty and GLSP, we are really going more into the direction that we want to put an abstraction layer that is as thin as possible, so you can really very easily just specify SVG, and that's with that specify the rendering. And of course, it depends on the use case, but we feel it makes it, for instance, extremely simple to specify editors like this one here, where you have maybe also a little bit more complex shapes and ports and all this stuff, because essentially you are just translating a diagram abstract model into an SVG.
Gerson has a question. So maybe Gerson, if you would like to add.
Yes, I have a question. Thank you for this very interesting presentation. So I'm Gerson Sani from Nantes in France. I was wondering if when you designed EMF Cloud, it was thinking to be a server, a kind of local server for local development, or also for distributed and concurrent environments?
Yeah, very good question. So at the moment, the EMF server, model server, is really meant to be used per user or per workspace. So when you have one user opening one workspace, you have one instance of the model server. It's not really meant to be like a collaboration repository where multiple users would connect to, at least at the moment. The main reason for that is we like to keep things very simple. And what we wanted to do is basically address exactly this problem to synchronize changes within one workspace or one application, synchronize changes between multiple widgets or diagram or whatever editors, so that they can operate on the same model. In Eclipse, this is really simple, right? You just share the editing domain or the resource set, and then you basically get that for free. But in this more distributed environment that we have here, where we also want to have very modular services that are really focused on a specific diagram type or textual languages, we don't want to integrate them with each other, but we want them to share the same model state. And this is really the main target of model server. Whether at some point there is enough interest in the community to add such like really multi-user scenarios to the model server, I'm not sure. Maybe that's a good opportunity, but at the moment we are currently just focusing on this scenario.
Okay, thank you again for the presentation.
Thanks.
Davide, I think you also had a question.
Yeah, hi Philip, this is Davide. Thanks for your presentation. Yeah, my question is related to the one from Gerson. So behind the model server, what's the plan in terms of the storage? I mean, where the models that you are going to edit are really stored? I mean, there is any plan to support some, some remote repository where you store the models, where you load the model that you're going to, I mean, in order to open and modify. So what's the plan in this respect?
Right. So the plan is to be very, very agnostic about that. So the in our products where we currently use the model server basically is just the resource set in a sense, the shared editing domain, and reads the model from arbitrary sources. Most of the time it would be XML files or DSL files or whatever files you store your model in, and would then just load them from there. So basically what you can do there is you just use EMF as you would use it today with all the resource factories that you have available there. You can even use CDO if you like with the model server, because essentially the model server doesn't really care where the model comes from. It basically just needs to read the model somewhere, and you can override this part where you actually read the model. So you can actually hook up CDO if you like, or whatever model management platform that you would like to use.
Thank you.
The plan is, I think, to keep it like that. But of course, since it's an open source project, if there is enough interest to develop in one or the other direction, then you never know where the journey takes you. But that's at least the current plan.
Okay, thank you very much.
Thank you.
Right, so Lea Brunsby has another question, but her mic doesn't work, so I will ask for her. And she says, maybe I missed these points, but is it possible to generate XML files or JSON of your models? And is it possible to do cross-reference between different languages?
Yes, exactly. So yes, that's for sure possible. Maybe I was no, not maybe. I'm sure I was. I'm sure not wasn't very clear about that. So you can think of when you look at this picture, neither the diagram editor or the form-based editors really know the model or understand the model, and these services that add sort of like the representation-specific editing capabilities on top, they also don't really need to understand, for instance, how the model is serialized. So in the end, you have some component like the model server or whatever you want to write yourself that reads the model and would then provide it to the respective services, and they would translate it to the representation specific stuff. So you can store the models in whatever information or format you like. So maybe that's the first part of the question. And very typically, especially for GLSP, you don't have one model, but you have maybe multiple model sources like the semantic model and the diagram coordinate information and stuff like that. And you can just read both of them and translate them into the graph model to be then sent to the server. And for to answer the second question with cross-references and navigation, yeah, sure, that works without any issues. So I can maybe not show the perfect example, but I can show at least an example. So here we have just a very basic example where you can, I think it's called next, go to next node. So there is just a navigation to the next node. And what that does, it jumps to this next node here. What happens in the background is that the client, which doesn't understand the language whatsoever, just sends a navigation request action to the server and say, I have a navigation request for next, whatever that is. And the server would then resolve what the next element actually is, and would then send this back to the client. Of course, this is now in this simple case in the same diagram, but it can be in an arbitrary diagram. So if I, for instance, close this and don't save, and I click here, this is essentially also a navigation request coming from the outside. So if it would be two diagrams, it would just open the other element and so on. I hope that answered the question a little bit. Maybe just one last thing, there is also this, I think it's called push. Yeah, you can open the example task with the at the task the example model with the task at the task push, and it would do it. And what this actually does, this is an opener configuration for the workflow file with a query name equals to push. And of course, the diagram client doesn't know anything about that, but it would send the query to the server in order to get it resolved, and then the server would send, you need to focus on this element with the ID blah, 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 and this happens to be the push element.
Right. Felicien has another question. I can read it, or Felicien, you can ask it yourself. So he says, in emf.cloud, is there a way to define node constraints?
Yes. So again, there is this constraints on multiple levels, I would say. So first of all, there is language constraints with respect to the meta model and additional constraints that you would have there. So this typically is more positioned here on this model management level, where you have the awareness of the full model. There you can do the model validation with additional constraints. Here there is currently a project going on also as part of the EMF Cloud project to add model validation to the model server. So this is work in progress, and I think already quite far. And then what would then happen is that the model server protocol, the API here, would be extended so that validation results can be sent, or that there are listeners for validation results, for instance, so that then these services can process them in any way. And I think it's important that these services can do that, because when you, for instance, change in this editor something that invalidates something in that is shown in this editor, then the model would show a validation result. This would then notify the diagram server. Only the diagram server knows which graphical element is mapped to a certain number of elements in the backend model. So it would then know, okay, this element now needs to get an error marker, for instance. So this is the intended way of handling that. And then last but not least, I think the second level of editing constraints is editing constraints, where you want to restrict certain editing directly. And this is, for instance, can be implemented also in GLSP because the editor needs to be aware of it, right? So for instance, I'm allowed to create an edge from here to here, that's fine. But I'm not allowed to create an edge from a weighted edge from here to here. So basically this wouldn't show me do anything, right? But I'm allowed to add an edge from here to here, weighted edge. So there is certain editing rules that can be then sent down from the diagram server to the client, so that the client can handle it directly. There should be also visual feedback. I'm not sure why this isn't currently not working. So there should be a mouse marker showing that this isn't allowed. Not sure why it broke. I just compiled the master, the development branch today, this morning. Maybe something broke.
All right. I said, well, there's another question. So I could suggest we have eaten most of the time that we have for the break and formal discussion. So I would suggest we make the last question, and then we start. We have a 5-minute break. That's okay for everyone. So the last question would be from Benedict. And the question is, does emf.cloud support model transformations, or only the definition, manual editing, and validation of models?
Sorry, could you please repeat the last part so I understood it until transformation? What was the rest?
Does emf.cloud support model transformation, or only the definition, manual editing, and validation of models?
So the short answer is no, it does not support model transformation per se, because I think it would be blunt to try to solve that big problem in the model server. but it basically it allows you to use anything EMF related or EMF compatible. So you can use whatever model transformation technology you like and hook it up in one way or another in the model server. So one example could, for instance, be that you want to load a model, then transform it into some other meta model before sending it, for instance, to a service like GLSP or whatever. So that can easily be done. You just have to write it with Java code in a sense that you need to invoke the model transformation, for instance, the ATL transformation from Java code there. But it doesn't provide any additional transformation support. But the rest you mentioned, like validation and so on, yes, that is part of or should be part at some point of the model server.
Well, thanks a lot, Philip. It was an excellent talk and a lot of information that certainly will be very useful for us.
Thank you. I was very happy to be here, and thanks for the opportunity to talk about EMF Cloud.
Yeah, well, thanks to you. So I suggest to have a 5-minute break, so that we start at 5 minutes. So the next presentation will be by Blaso Nastov and Matthew Alon on cloud modeling and model scalability with GenMind model. So Blaso and Matthew, you can already share your screen and so on, but I would suggest to have, in the meantime, a 5-minute break.
All right, that's good. I mean, can you hear me?
Yes, perfectly.
Perfect. Can you see my screen?
Yes, we do.
All right, perfect.
Hello?
Yes.
So let me check. So maybe we can
start.
Start whenever you are ready.
All right. Well, I'm ready, so I will start. First of all, many thanks to Juan for inviting me and my colleague Matthew along for this presentation about cloud modeling and about model scalability with GenY model. And because we are two, I will present the first half of the presentation, and then my colleague Matthew will continue to the second half and finish up. My name is Blaž Nastov. I have a PhD in computer science and in particular in the domain of model-based systems engineering. And I'm currently a research director at Exilience. My colleague Matthew has also a PhD in computer science in the domain of model-driven engineering, and he's currently a research engineer at Exilience. So before we start, a few words about the company, Exilience. It is basically a spin-off of the French National Research Institute in Computer Science. It was founded in 2012, even though the initial ideas date back to 2008. The founder of Exilience is Alexis Müller, and basically he was a researcher at INRIA. And he was having these ideas in 2008, and that is how he started the company. So between 2012 and 2015, several releases were made, and the final version was released in 2015. And GenY model was one of the first cloud modeling platforms back then. Exilience has currently two products: the GenY modeling platform that supports modeling tools for software development, such as it supports standards such as UML, Archimate, BPMN, and others. And we have another product called Agile Architecture Factory, and this is basically for DevOps. I mean, the goal there is to bridge the gap between architects, operationals, and developers. Just to mention a few numbers, so we currently have, the users have currently built more than 1 million models by using our platforms. We have a bit less than 1 million users, and they come from all around the world. Some of our customers are big corporations like IBM, Amazon, Cisco, Huawei, or Renault, for example. This is the agenda for today's presentation. Just to mention, we don't have a technical presentation. I wasn't aware that we should go into any details like presenting code or some stuff like that. But we have more of a general type presentation, introducing, for example, key features of our platform, what are the requirements to have these features, and so on. So I'll first start with an introduction, then I'll talk about the feature of Gen9 models. And I mean, I'm going to talk about cloud modeling, about model collaboration, about scalability with our platform, and about some other feature. And note that the feature that we are going to present are not exhaustive, which means that Gen9 model platform has other features that are not going to be presented here today. And at the end of the presentation, my colleague will conclude. Well, generally, systems are becoming more and more complex. For example, if you compare a mobile phone from back then, like Nokia 3310 with a smartphone of today, let's say like an iPhone, you can see that they're completely different. And I mean that in terms of functionalities, in terms of services, in terms of required performances, and so on. As the difficulty increases, I mean the design of these systems become more and more difficult. And so the design methods must keep up with such continuously increasing complexity. So generally and classically document-based approaches are becoming more and more obsolete, and engineers are starting to use model-driven approaches. And this is basically because models can be consumed and processed much easier than documents. On the one hand, they have all the general advantages of the digital world. For example, they can be easily stored, they can be sent to other users, they're archived, they're never lost, they can be easily copied, and so on. But in addition to these general advantages, they also provide a better representation for improved understanding. They can be used for verification and validation, for model correctness, and this in turn will improve the confidence of stakeholders that are using models for decision making. Of course, models can be used for automatic generation in order to generate a part of the system we're trying to model, for example. They are also scalable, and at the end of the day, they can reduce the time of the market. So we have some gains like economical, for example. Models are nowadays built and managed by modeling tools. And we have modeling tools for more than 30 years now. But despite being technologically powerful, desktop modeling tools currently on the market are not designed for agile development, and in general, they lack. I mean, our clients has expressed some criticism about such tools. So they are difficult to collaborate, they're complex to use, and they're generally reserved for experts. They have a negative perception by development teams, and this is why developers generally do not use modeling tools. They have, of course, an installation time, and they have to be managed for different upgrades, which is very difficult when deploying such tools in large organization. For example, if you have to install thousands of modeling tools on each different computer in a company. As a solution to this problem, Gen9 model offers a professional cloud modeling environment. It allows exchange and model sharing and real-time editing of this model. So the idea behind it is to collaborate in real time with other architects to share the models in just a click, and in order to have a better understanding of different needs of all the different collaborators. GenMy model also allows hosting and versioning of models. And when I talk about hosting and versioning, I mean Google-like, Google Drive-like hosting and versioning. So the idea behind it is to archive the model so that they are never lost. And GenMy model also proposes a code generation, which is customizable in order to meet the different needs of different collaborators. Right, so the key feature of GenMy model. Here's an overview of the key features. So we are going to talk about cloud modeling, about code generation, about model scalability, collaboration, of course, model versioning, and traceability. Well, basically, cloud modeling is the combination of modeling and cloud computing. So we cannot talk about cloud modeling before explaining, for example, what cloud computing is. And basically, cloud computing enables company to consume a resource as a utility rather than having to build and maintain an in-house infrastructure. If you think about it, it's just like, for example, electricity. So you don't have to build a power plant and a system for electricity transportation in order to use the electricity at your home, but you only pay for the resources that you're using, in this case being electricity. Cloud computing provides a couple of advantages, and here note that the advantages I'm presenting are not exhaustive, meaning that there are also many other advantages that I'm not going to state. So the first one being elasticity, the ability to scale up or down quickly and easily in order to meet demand. Users can, they pay only for what they use, and they are not paying for what they are not using. So we have a granularity level depending on the use. And the third advantage being self-service, meaning that you don't need IT administrator to provision and manage different resources. So everything is done for you and prepared for you. As I previously said, cloud modeling is the combination of cloud computing and modeling. So the idea behind it is to combine the technological power of the classical modeling tools with the advantages of cloud computing. And the idea behind it is in order to improve some limitation. For example, they're simple to use because ergonomy is a key factor. And this is especially true when we're talking about web application. I mean, if the application is not ergonomically well designed, well, then users are not going to use it. I mean, they're automatically will continue to another website. They're simpler to maintain because you don't need a maintenance administrators. Of course, there is no installation time. Collaboration is native as for the majority of the web application, and there is a centralized repository, model repository, so that models are never lost. In order to build cloud modeling, you need to respect several requirements that comes from the modeling perspective. So the first one being conformity to standards. And I mean, nowadays there are a lot of cloud modeling editors that are not basically cloud modeling editors. They are simply cloud drawing editors. And this is because they do not provide an underlying structure or an underlying model behind the representation. It's simply a photo of the model. The other requirement is being complete to standards, and by this I mean the ability to cover all the concepts, all the constraints and annotations and diagrams that are defined by different standards. And last but not least, being similar to classical tools. And this requirement is very important because nowadays the majority of modeling tools users are using the desktop modeling tools. So when they make the transition from desktop into cloud modeling platform, these transitions need to be aced in some or another way. And for example, being similar to the classical tools, for us, it's an advantage. But this is a tricky one because, as I stated previously, classical desktop tools tend not to be ergonomical. And here we try to make a cloud modeling platform where ergonomy is a key factor. This is our platform. So when you create an account, you go to the dashboard, and you can use the dashboard to create models, to open up these models and modify them, to invite different users. And there are also a couple of other features that we're not going to talk about today. And when you open the model, you have basically an editor in your browser, and you can use this editor to create different instances. For example, here I have an Archimate editor, and what you see is a diagram for the Archimate editor. The second feature is about code and document generation. And the idea behind this is, instead of manually writing everything, I mean the code or the document, the idea is to reuse existing models in order to generate either the documentation for the system, because I mean sometimes document models are used as a design and as a means for documentation. But also this is used to generate parts of the system. And when doing this, we have important time gains and important productivity gains. Again, for the generation, there are a couple of requirements. So the first one being the generation templates. I mean, you have to provide a database of different templates that users can use in order to generate their code. And here I mean pre-designed templates that can be directly used. For example, let's say you have an UML model. A basic template would be a transformation from UML into Java code, for example, or C code. The other requirement is about customization, the ability to customize the template in order to adapt them to the needs of the customers or the modelers. The third requirement here is about incremental generation, and we've talked about it, I mean, in the first presentation about this. So this is the ability to regenerate a part of the model. And in addition to that, we have added, for example, the ability to relate such incremental generation with a Git repository, so that the Git repository is automatically updated when you generate the code. And last but not least, the preview requirement, which allows users to view the code or view the documentation before they generate it. So this is an example. As you have seen, this is the main editor where you can edit the models, but we also have views for code generation. And so here you see a script for code generation that has different functions like auto-completion and so on. And for example, this is a result of documentation that is generated based on the Archimate model that I have just shown you. Right, so we're coming to the second part of the presentation, and this is where my colleague Mathieu Aron will continue.
Okay, thank you, Vero. Okay, do you see my screen, my presentation?
Yes.
Yes, thank you. Okay, so now I'm going to introduce the other key features of GenMy model. The first one concerns model scalability. Just a quick reminder about it. Model scalability is a property of a system to maintain its level of performance when storing and managing very large models, or VLM. We will use this acronym in the rest of the presentation. Generally, the benefits are the following ones. A time gain, because with model scalability, you access to VLM without a loss of performance. Productivity gain, because VLM modification are done without a performance loss. And resource gain, due to the fact the resources not allocated to VLM handling are used for something else. Concerning model scalability, there are different requirements. The first one is about model loading. That is to say, effectively display and navigate into VLM content. The other requirement concerns model artifact search, the possibility to efficiently search artifacts, for instance, by name, meta type, or stereotype. This is what we are implementing in our platform, in the GenMy model platform. We face different problems. The first one was about efficient model access. That is to say, be able to access to any targeted VLM part without a performance loss. For this, we are implementing the lazy loading mechanism. That is to say, modelers are able to access to load model parts only when access is required. The second point was about VLM understanding and browsing. The possibility to understand and navigate easily between the various parts composing a VLM. For this, we are provided a mechanism which allows users to split, to fragment these models, these very large models. We call these parts submodels. And here we take advantage of the first point concerning lazy loading. So because you can lazy load this part. System models form a model hierarchy. So this hierarchy allow to understand and browse easily in very large model. The third question was about effective model search. That is to say, be able to find a model element in VLMs at the same efficiency than in other models. For this, we have implemented the model element indexation on each artifact, on each model element creation or update. I talked about this earlier. In GenMy model, users can search model element by their name, type, or even stereotypes using this mechanism. Another key features of the GenMy model platform is collaborative modeling. Collaborative modeling allows users to build models collaboratively. So for this, you need to have different governance rules, access rules. But just before continuing to present this, just a quick reminder about the two kinds of collaboration you can have. The first one is the asynchronous collaboration, where interactions are time shifted. And the second one is the synchronous collaboration, where everyone interacts in real time, for instance, like in Google Doc. Some years ago, with us at the University of Lille, a PhD student made his thesis about collaborative modeling. This thesis was titled Toward Efficient Collaboration for Modeling Tools. It was Michel Dirix. So concerning collaborative modeling, there are different requirements. The first one is access management, which is a key factor for effective collaboration. For this in GenMy model, we have defined some mechanism about team management. Users can assign role to other users. We have defined also a custom access management, for instance, access to particular model parts. The second requirement was about awareness. When we say awareness, it's the fact to be aware of the work of collaborators when they enter or exit the environment, and even when they are making some modifications in the models. The third requirement is agility, which means providing the means for agile modeling via collaboration. For this, in our platform, we provide some mechanism to allow users to make to-do lists, to assign a task to other users, and even to use and to define and use bidirectional links between these tasks and model elements. We face different problems concerning collaborative modeling. The first one was about synchronous collaboration latency. More precisely, the question was, can we eliminate the latency as in video games? For instance, using rollback mechanisms. The second problem was about undo and redo action. Can users see actions cancelled or redone by others without any conflicts? And the third problem concerns general access management versus custom access management. And when we are talking about general access management, it's the fact to consider to not consider any type of users and just to lock a model for when any user modify a model. And custom access management is the possibility to define different kind of access. And the question was, can a general or custom access management be used as a model? Another key feature of the GenMy model platform was about model versioning. Again, just a quick reminder about it. Model versioning is the creation and management of multiple releases of a model, all of which have the same general function, but are improved, upgraded, or customized. Generally, we consider for model versioning the following advantages. We can compare model versions, identify the differences, roll back also modifications, and keep particular versions. Concerning these features, there are different requirements. The first one is the possibility to compare a version, and it identifies differences, like in EMF compare, for instance, and the possibility to graphically represent conflicts on models. The second requirement is a partial versioning, that is to say, be able to version a part of a model. And the first one concerns alignment, where we mean here alignment with other versioning system, aligned with the versioning of standard exists. For instance, we can talk about the use of UML operators, for instance, the merge one. Here we have a screenshot of our platform concerning version management. So you can create a different version for your current project, your current model. You can define a different. You can restore this version, of course, and you can view them. Another key feature is model traceability. Model traceability is a process which allows to record the design process of a model during its life cycle. In general, we consider the following benefits. We can keep track of all changes in the model by any collaborator, consult changes in a particular approach in time on restore model, or a copy of model to a particular point. There are different requirements for this feature. Simplicity. We mean by this an intelligent representation and management of recorded changes. We have implemented a video player-like solution for changes management with the possibility to play, pause, go into the previous change, and so on. Another requirement concerns version traceability, which is related to another feature I've introduced before, which is the versioning. In our platform, you are able to tag new versions, define them as major, minor, or fixes. You are able also to animate changes for particular versions. Two other requirements So another one is the branches traceability, which is related to asynchronous collaboration. It will be interesting to be able to animate several branches, display changes from branch creation until merging. Another one concerns filtered traceability, that is to say, only display particular modifications, display model structure modification, or even modification on one element. So here you have the player I've talked about. So you have a model, and you have the possibility to display the changes, the evolutions of the model using the plays, going to next change, etc. You have also the possibility to download a particular version from a point in the history of the model evolution. So to conclude, we have presented different GenMy model feature, and we can see there are different. There are some crossbreeding between the Locomote objectives and the ANSYS features, notably the following ones: the clone modeling, where we use models coming from a large number of users, and which allow to install, maintain, and which facilitate the use of modeling platform and its artifacts. Model scalability, which allow to manage very large model, and where we have a gain in time, productivity, and resources. And another key feature, which is the code generation, allowing to produce software application parts from models, and where we have a gain in time and productivity. We have different perspectives. Currently, we continue working on the discussed points and also on other questions like interoperability, model verification, and validation. We also use our features for the modeling of critical infrastructures and assessment of their resiliency. For this, we have a PhD student which work on digital mockup and digital twin, notably. And we are working also on a pioneer project, a French project, with the concept of clone modeling and resilience assessment, and also 3D reality capture, notably augmented reality and virtual reality. So thank you for your attention, and if you have any questions, don't hesitate.
Thanks, excellent. Do you have any question? Do you have any question you would like to ask? Well, in the meantime, maybe I can start. Yeah, it was so nice to see all these features and how well they integrate to each other. I was thinking, I think it would be a question for Blaso. So it was not clear to me whether the set of modeling languages that are supported by GenMy model is fixed, or I, as a user, can define a new modeling language, maybe through a meta model, and then define my own models.
This is a very good question because it joins with the ANR project. First of all, at the beginning, I mean, the platform had a fixed number of languages. But then when we started the research project, and because we have different partners from academia, they wanted to design DSL-like languages. And these were languages specifically for the design of critical infrastructure. For example, they wanted to have a language for the design of the resilience properties, another for the design of the context, and so on. But they didn't want to use the different standards. I mean, the general standards that we propose. And in order to resolve this problem, we have made a solution based on UML profiles. And with this solution, I mean, we can either extend UML and adapt it to different needs, but also we have extended UML profiles, and now they're adaptable to any of our standards. For example, you can use UML profiles to adapt a version of EMF, to adapt a version of UML, and so on. And by that, by using this mechanism, users are able to define their a whole new language, for example.
Okay, cool. Any other question? All right, so I have more questions from my side. So you have mentioned that you make available code generators and then you can customize those and so on. But one thing that normally engineers do in model-driven solutions, for example, within Eclipse, is to apply model transformations, to generate a model from another one and so on. Do you plan? Do you support that? For example, transformations written in APL or things like that? Or do you have plans for doing that? Would that be interesting for your tool?
In terms of model-to-model transformation, for example, we have a couple of examples. For example, being able to transform, let's say, BPMN model into a BPMN standard or into another type of standard, because some of the standards have different underlying representations, and based on that, we are able to define to do this type of model-to-model transformation. But just know that what we have now, it's fixed. I mean, we don't have editable or customizable model-to-model transformation mechanisms. Anyway, you can use the model-to-text mechanism in order to transform your model into a specific formalism, and then you can import it back into your modeling platform, for example, and that can be done.
Mm-hmm. Yeah, cool. I would have another question, but concerning scalability. So perhaps this is more for Matthew, because you have mentioned something quite interesting, which is you split the models, creating kind of hierarchies. I think you mentioned, but I was interested in knowing whether this is done explicitly by the user when creating the model, or there is somehow a strategy for fragmenting the model by the engine, or how this is done in practice.
Okay. Currently, this is done manually by the users. They decide to split the model. We haven't any algorithm or mechanism allowing to split automatically a model. But yes, I think in the future it will be interesting to do this. But we need to study more this kind of thing, of course.
But then is this something that this would be transparent to, for example, the code generator? So could the code generator work on the structure of fragmented models?
I can complete the response to Matthew. We have a client that were using using Spark systems, and they had a model with I think it was 9,000 or 8,000 diagrams, and it was several gigabytes model. And the problem with that was when we have imported it directly into the modeling tool, the tool has crashed. So we had to work on scalability and how to divide this model and so on. So in this case, we have jointly worked with the experts, with the modeling experts of that company, and they gave us the main rules that were used to split the model. And when I say split the model, I do not, because we have two types of splitting. You can either divide the model into several submodels, or you can basically use EMF proxies, for example, in order to reference different types of the model. But currently we don't have a mechanism that works for everybody, because we believe that the splitting of the model should be jointly done with the modeling teams. They are going to give you the rules how to split, how they want the model to be split, and then this mechanism should. Currently we manually write the code that is going to split the model, but maybe we can do, for example, an automatic mechanism that uses such rules, for example.
Yeah, that would be very interesting.
But there are a couple of questions related to scalability. For example, how, as you mentioned, how do you divide the model, and then again, when to load, for example, different parts of the model. If the user opens the model, should you load some part or not, etc.
Yeah, that's good. Yeah, I think Massimo has another question.
Yes, it's Massimo. My question is about portability. So the question is portability important for GenMy models, in the sense which artifacts can I take out of GenMy models and use in another environment, and then take them back in GenMy models when I want to? I suppose some EMF models are, but what are all the artifacts that I can actually reuse somewhere else? And is that an issue for your users?
This is what we mean when we stated the interoperability line. By interoperability, we mean the ability of our editor to be exported, models of our editor to be exported or imported in another editors. And of course, we do this, but only for standardized models. For example, if you take a BPMN model, there is a strict specification about the structure of the model, but also about the representation of the model. So in this case, we can export the model into the specific in the specific form, and then this form can be imported by any tool that need to use the model. And of course, if the second or the third party tool has export mechanism, I mean, you're going to import the model, then you're going to edit it, and if this tool has an export mechanism, then you can of course export the model and import it back into our tool. But there is another also type of interoperability, and we are currently working on it. And this is the ability to relate together desktop modeling tools and cloud modeling tools. For example, let's say that you have 10 users that are using Eclipse on desktop, and then you have 15 users that are using the cloud platform. And the problem here were how can they all collaborate on the same model, for example, and we are currently working on this problematic.
And let's say in a world where cloud modeling is standard, you would have, I suppose, also portability with Theia, and so user could use different cloud editors for editing the same models. Is it?
Yes, of course. For example, let's say you choose another BPMN in the cloud editor, for example, and of course the majority of this editor would support import, will have, I mean, import functions. And in this case, you can export all the models of the GenMy model platform in JSON form or in XML form, or in the specific form that is required by the standard, for example, and you can import them back into the third-party platform. So yeah, this can be done. Maybe.
Okay, thank you.
Okay. Any other question you would like to ask? All right, then if not, thanks a lot to both of you. I think it was very, very nice especially for the ESRs, because your tool touches many functionalities that are somehow very relevant to our ESR. So I'm sure they have appreciated that.
Thank you for the opportunity you have given us.
Perfect. Right, so the next presentation will be given by Pablo Diaz from UBrown, and the title would be Enterprise Level MDE and Semantic Engineering, a case study.
Yep. Hello, Juan. Oh, 1 second, let me put the camera on. So
yeah, maybe you can share your screen.
There we go. Hello. Hi there. Nice to see you. Okay, let me share the screen. 1 second. should we see my screen just right? Is that okay?
Yes, we do.
Yeah, okay. All right, so shall I start right away?
Yeah, sure.
Okay, well, before I start, thank you very much, Juan, and all of Locomote in extension for allowing me the opportunity to present and allowing us the opportunity to show a little bit of what do we do at uGround and how do we approach the scalability issues from the perspective of the enterprise level. So no, which is a bit different on the paradigm that user level or university level, so different paradigms. Okay, so well, before we dive deep into the topic, who am I? My name is Pablo Diaz. I'm uGround CTO. I've been at uGround basically since the beginning, almost the last 9 years or so. And I manage the team, or I lead the team, sorry, of developers for the development tool that we'll talk about and the redistributable platforms to our clients. So I studied mathematics, theoretical mathematics, and then a master in theoretical mathematics. And we are related with Locomote, hosting the ESR2, so the scalable cloud-based heterogeneous model, which is a very, very, very interesting topic. Okay, and also before I start, who is uGround and why what we say may be of interest? Well, for the last 9 years, we have been developing 2 sets of tools, one of them in the development side, which is a ontology-driven development tool, which is called ROSE, that allows us to define what do we expect of a system to have at the end of the day. And then that model or that structure of models, because there are several of them, as we'll see in a little bit, would be transported to the execution layer and being interpreted by a set of interpretation structures, okay? This that we call semantic engineering, and we'll talk about it, and how it has allowed us to, as we'll see right now, grow and scale in operations to several different type of clients, but most of them big level clients. We're counting as thousands of concurrent users or millions of transactions per hour. Okay, all of it, as we'll see, it's a web-based structure, both development and execution, and it's agnostic of the niche or domain, particularly that we're talking. So we're a very decentralized company in that case, that we work with several different type of clients and a research directed company. Okay, so now let's get into the topic. So model-driven engineering, and how does it work at the enterprise level, and and the semantic engineering behind it. How ROSE and the technology of expanded model-driven engineering, if we put it that way, allows us to develop enterprise-level software and all these structures behind it. So before anything, what is a scalability? We need to start considering that scalability is not only directed towards the amount of data that we need to manage in any production environment or any given production environment. So there are several types of databases and data management structures that would allow us to scale the amount of information that we're managing or loading or processing at any point in time. That is one perspective. There's another perspective of scalability that is aimed towards the users. So what is the latency of the information? So if I have any developed system, it doesn't matter if it's very big or very small, for how long does a user has to be waiting in front of that screen? Okay, the difference between locally styled systems and cloud computing, I'm not gonna get into it, but it has shifted that paradigm greatly, because now we all think about latency and what is the distance between the data, the processing, and the user, and how can we optimize or reduce the time that the users devote to waiting, just being there. There is another one that is normally less considered and is going to be the main topic of this presentation, that is the developer perspective. So normally in enterprise software, things tend to grow, not considering the amount of information that you're managing or the amount of users that you have, that those may be a lot smaller in the enterprise level than in the consumer level. But in the perspective of the structures and the amount of information that we need to manage, not just to handle, just to manage, tend to grow a lot. As a little example, if we consider the developer perspective as to how many things has a developer in uGround has to manage or has to deal with, excuse me, I don't know what happened there. Has to deal with in any given point in time are counted by the thousands. So it's not the same thing to do a little system or a little environment when you have tens or dozens or 100 or a few hundreds of just considering orthologies or elements. But what happens when you have to work with the thousands of them? So what happens when you have an environment like the first one that we have in here, which is the core environment of your ground, where you count over 6,000 ontologies? How can we scale up the development environment, not in the data perspective, but in the user relationship environment, as to how a web-based structure can allow me to play with and develop and further extend the information that I have to detail in the system without, well, literally talking, creating a nightmare for the developer. The same way, if we consider scalability or growth, what happens when that keeps on growing and we end up with tens of thousands of attributes or element definitions or tens of thousands of user controls? Okay, how does the model-driven engineering technologies and how does the scalability of the semantic engineering on top of that allow me to extend the systems to make this viable at the end of the day for both the developers and then the end consumers, which are the companies in this case? Okay. Now, before we get into the how, let's talk a little bit of the who is behind all of this. So if we consider model-driven engineering by the definition of Wikipedia, just the definition of Wikipedia, we can see that it's very strict into what it does and how should it do it. Okay, first of all, we'll know that model-driven engineering, as referred to code, or the modeling techniques, better said, as referred to code, is first an abstraction and an automation. So the first thing that we do when we model anything, and it doesn't matter if we're going to generate code, we're going to interpret code, or we're going to develop in the metadata-driven environments. Okay, the modeling tools allow me always to first abstract and then automate. Okay, that's the standard behind it, and that allows us, at the end of the day, in the companies that we're working in modeling environment, to guarantee the execution of whatever we're doing. So if we paint a diagram, as we've seen before in previous talks, that diagram will be executed because it's abstracted and automated its execution. Okay. The second part is the usage of semantics to express what I want. Code, again, as refers to modeling, as refers to code, allows me to work in the common language somehow, or common expressions, not in the machine language itself, which would be a procedure on a local environment, but in a more broad description as to what it means. If we take, for example, a BPM as an example of a modeling tool, a very simple one, well, the node and the connector are something that are, well, semantically correct for the humans and not so much for the computers, where the computers what see is a transition or a function or a procedure or a variable, which is a different thing. Now we get to the third part when we consider modeling. And this is where modeling in the larger scale systems tend to fail a little bit. And it's the domain specific part. Now, naturally, when we're talking about a specific environment, let's suppose a CRM, an ERP, or a logistics development, okay, the domain specific is very clear. A box is a box and I have to deliver it, or I have to sell it, or I have to manage it. But at the end of the day, the box depends in the system that I am, which is the domain specific or the silo that I'm going to consider. Okay, this is the broad definition of it. But at the enterprise level point of view, this actually raises some issues when you go towards larger scale environments. The main issue is that even considering the goodness of modeling with the high standards of development and the guarantee of execution, the problem of developing in any sort of code or modeling is that it creates vertical silos or local functional and developed silos that do not work or cooperate so much correctly with the other ones. So if you go to larger scale enterprises, when you have tens or even hundreds at some point of systems, different systems, the ability of relating one to the other or integrating just the data from one to the other becomes a real nightmare for any organization. Now, the problem of this is that even though we can develop more and more and more software from the idea that I have nothing, then I have a system, and then I try to evolve that system, that increases complexity in an exponential factor. So every system that I add from nothing to something, to my whole enterprise or my whole structures, or to my lines of business, or just to the developers, becomes an extra factor of complexity to all the sets of layers behind it. So to the developers, because they have to learn a set of connectors, new functionalities, to the managers, because the integration between all of these systems are normally very complex. And at the end of the day, to the users and to the line of business, because you'll have to go to a place to do something and then to another place to do something else, or the continuation, or just the same thing at some point in time, okay? But if we consider the other point, we consider the enterprises, well, the enterprises need development frameworks that are unlimited, so are transversal, not vertical. Just the complete difference of the definition of domain specific. They need domain agnostic or niche agnostic. They need to know that they have an element, an artifact, a concept, and a structure, developed something that can apply to any part of their business, no matter what they use, no matter what moment in the process of the company is. And that is one of the critical elements that we think, at least from our perspective, we'll see on the applications of modeling and modeling towards enterprise tools. Okay? So the evolution of these ones will allow us to conquer those kinds of environments. At a point in there, Locomote is actually working towards that standard. So growing something that is agnostic to a structure and is big enough that can capture multiple different sets and elements of the domains, and will allow both the developers and the end consumers, companies or people or whatever it is that the software developed, that transversal developed structure instead of that vertical niche or vertical silo that works good for 1, 2, or 10 processes or 1, 2, 10 structures, but it doesn't really work correctly when you're working with a complete enterprise or a complete system. Okay. Okay, in order to be able to produce an environment from the developer perspective, okay, not from the end user. So from the developer perspective, in order to produce a development environment that will allow us to put any semantic definition and any possibility in it, we'll need a certain level of restrictions or things that has to have. The first one is that it has to be niche agnostic. One of the main problems of specific code or modeling tools is that they are aimed or they are directed towards a niche. So it's either a diagram and then an organigram niche, or it's either a data structure and table and then forms, or it's either directed towards a parallel functionality and parallel computing and microservices, but they're directed towards a specific niche of development. That obviously implies that the execution will be in one niche. So it will be either a B2C structure, a CRM, or an ERP. It doesn't matter. Okay, they will be directed towards one niche. But we need a niche agnostic structure. We need a system that is autonomous. That means that it will somehow decide, just don't go in depth too much into that part, but it would have several different proprietary decisions as to how it stores the executable artifacts. Because when you start growing in a transversal way, if your system stores, data definitions, then you don't really care as a developer if it's storing it in a relational database or in a non-relational database, because it's just it's safe. That's the point. The third part needs to be ontology driven. And we'll talk a lot about that, about the artifacts, the relationship between artifacts and ontology driven structures. And the main point is that it has to be ontology driven. And those ontologies have to have two properties. First, they have to be self-referential. That means at the end of the day that for developer perspective, the generated tree or the view of the dependency between the different ontologies and the elements that you are developing are very clear. So you don't technically create an ontology, you just add different attributes or elements of different ontologies into one unique one that you are going to use on the next step. And also, it has to be recursive. So an ontology has to know that itself exists. This will allow us, as we'll see later, to manage correctly the exponential evolution about the semantics and the information that every ontology needs to have and needs to store. Okay. It also needs to be self-organized, and it's very important that the system is the one that somehow decided, and the somehow part is very interesting, how it structures and how it presents certain parts of the information. This doesn't mean that there is an external brain that works autonomously and tells us what to do, but it somehow has to tell us that there is hundreds of elements related or correlated, or there is thousands, as we've seen before, ontologies in one single place. We should be able to navigate them in a semi-simple way. It cannot be a continuous list or a continuous endless diagram, okay? And finally, it has to be hyper-scalable in the three, at least in the three terms that we saw before, and maybe many, many more. But it has to be scalable in the usage of the data, because data tends to grow obviously exponentially, as we already know, and the databases behind that are critical. It has to be hyper-scalable in the user perspective. So what I've modeled at the beginning and then executed has to be transparent if it's 10 users or 10,000 users. It has to be agnostic to that level of usage that I want to give it. And from the perspective of the developer, we need to have a system that includes all of the structures and the definition, not just a partial matter of them and then some code on the outside. It needs to be all held within the same place. Okay. So those are basically the critical environmental elements that our system needs to have. Okay. So this is where semantic engineering comes into play. Well, semantic engineering starts at the idea of modeling, and modeling on the canonical way, as we saw before. Okay? It starts on that base. And then we started working a lot of years ago into how to expand more and more and more, or how to include more capabilities of definition to the users and autonomously execute them just by a set of interpretation course. If you want, we can talk more about that at another point. It's not part of this presentation. But the semantic engineering, what allows me from the developer perspective, is to expand the amount of definitions that I can input in a system, and those were transparently being executed at the end of the day. Okay. This expansion and this capability is actually, it actually has the points that we saw before. It's agnostic from the definition of the system. So it actually doesn't matter if you're working for a bank, for an insurance company, or from human resources or logistics. It's autonomous in its definitions. So we can actually keep on adding more and more and more structures, and it will actually store them on the backend. It's clearly ontology driven as any model-driven environment, and it's obviously self-organized and hyper-scalable, as we'll see in a minute. Okay. Now, when we talk about hyper-scalability and self-organization, it's not something that different as we actually do every day. So let's put a little example of what does this mean. Okay, so when we define something to be able to model it, as we see, let's put a little graph. Well, we say we're going to define a modeling tool that allows me to define ontologies, and that each ontology has the definition of attributes as elements that define the ontology. This is fairly simple and straightforward, like a client has email and name. So it's just the definition of the client, and I will put in a place that the definition of the client. Now, if we let this grow a tiny little bit, actually, we can say now that the ontologies had attributes, and now we want to include certain type of ontologies. How do we access that ontology? So how do we build it? And then what is the user relationship with that ontology? Just the definition of it. Well, if we put on the example of the client, what we have is a client had a name and an email. That doesn't change, so that's the attributes. And then we define that the client is stored whenever it's recorded or filled in the information. No, it's stored in an SQL database, which is something very simple. And then when we present the client, we want to present the ones that start with the letter A, which is just because our system wants that. And then we want the user to have the option to create it. So it's just a fairly simple definition of what a system does. No? A screen with a form, maybe not even a form in this case, but a screen with a certain level of tabs or columns. If we let it grow a tiny little bit more, we'll start defining what is the structure of our ontology better and better and better. So in this case, our ontology, we're adding on top of the elements that we have before, a little bit of a cycle of life. So where's the states of the ontology, and what is the user relationship with that state? So what actions can a user take in order to modify or evolve or change the state? We're using security in the ontology, so who can do what within each and every object in execution. And we can input forms as to what is the order and the position and the screen of the data that I want to fill in to have the information stored in the database that I set. If we put it in terms of execution, so if we go to the execution layer on the developer side, what our developer will say that we have our client with the name and email, the SQL, filter and listed the ones that start with an A and with the option of a new client. But we have also created another certain level of elements, like our client can be active or pending, that the active or pending environment is associated with an action of the user that is activable. So a user can go and say, you're active. As an action or an option of the client itself, we can say that the client is only manageable by the commercial department, not by anyone in our company, just by this particular department, but in this case is viewable by any other person within the scope of the company or within the structure of the company. And finally, well, that it has a group management. So we have the creation, delete and update elements associated with it. So we have the data in a form and then we can redefine the forms. Well, this is a very simple way of seeing how exponential is the growth of the definition or the artifacts, sorry, that at the end of the day are centric in an ontology. We just give it more and more and more and more options and more and more and more elements that will define the core element as to the ontology itself. Now, if we let this grow enough time and we apply the previous characteristics that we said before, well, we end up with these types of structures that are tangled, not bigger, but actually allow any modeler or any developer to configure any system, and that is the trick, that is the correct part, any system on real time in the cloud. Now, what we're seeing right here are 4 little, technically talking, examples of how does semantic engineering plus model-driven engineering allow us to define, just model, any structure agnostic to the execution and with all the capabilities that we said before on real time. Now, all of these environments presented as diagrams, as we saw before, actually allow us to define them in forms, in diagrams, by a scripting language, by JavaScript. So there are multiple ways of accessing the same amount of information as to depending on the moment of development of a system, which is at the beginning is very small, but it starts growing. So when we actually pass maybe a few hundred ontologies related one to each other, diagrams are not so efficient. So maybe we can go more towards form and search engines, and then maybe we can even go to scripting languages to be able to increase the options of the developers within the expansion of the system itself. Now, as we said before, if we let this to grow over time. Now, what does it mean to grow over time? So as I said before, we've been working for the last 9 years on this and into the ability from the developer perspective of having a big enough tool that will allow the person to configure and to document every single piece of information they will need to deploy any system on any client, all in one specific place. If we take a little bit of the statistics to what has happened during the last year with us, we have been creating for the last 9 years more and more and more and more definitions of ontologies, meta-ontologies, meta-ontologies. We can keep on going up. Actually, these are the actual execution numbers, and we're in the rate of over 1,700 ontologies per year, stable for the last 9 years. This actually allows to have a massive database with the meta definitions of how does a something, client, a bill, provider, anything that you may think of in a database, and then is reusable for any of our clients and re-executable for any of our clients, which is the interesting part of how those modeling in the larger scale works. Now, but if we only not take the ontologies, we actually take the expansion of rows itself. So how can we expand the modeling tool to be able to acquire more semantics and hence develop more systems and be more niche agnostic? We can see a couple of numbers that are fairly interesting. On the left side, we have the last year's growth of rows itself and how many more options, how many more data elements, how many more ontology types can it accept in order to define better or be more granular in the definition of a company. Here we're working in a 5% rate annually, which is a normal number, it's an acceptable number. But if we project these same elements and only from the perspective of the ontology, not from the perspective of the whole environment or the whole model solution towards our client, this grows under a 10% rate stably every year. That means every client that uses this sort of techniques, every developer, and hence every recipient of the developed element that works with this sort of technologies can increase greatly in a year basis without adding complexity to the technology itself, just by expanding the definition of the models. Now, if we take in consideration the whole element, so the broader structure, we actually grow towards a 15% rate. Now, this graph may say more or less, but one of the most important parts of the graph is the actual number of elements that are generated. This means, well, this number shows us, sorry, that at Rose, we have over 110,000 developed artifacts, elements that are reusable within any system, agnostic to the execution itself, where you can just tally or redefine specifically what you want to a specific client, and then that will be automatically executed at the disposal of the developers and the clients. So these sort of techniques allow us to create very big databases that define the structure of the companies, which is the application itself that it has right now, okay? And hence model in a transversal way what any company or any business company has. Now, with all of this, at the end of the day, for the developer, okay, what it receives is a web-based tool that works with it into what it is wishing to do. So that means, as we see here, a couple of examples. It's a web-based tool where you go in, you have as any tool, as any developer tool, your diagrams, your entities, sorry, this is in Spanish, but your entities, your elements, and the navigation towards your elements. But at the end of the day, allows the developer, the model in this case, to define what is expecting to have in the client side as to the extraction of the ontologies that we saw before, and that will automatically be executed. No matter if it's working in a diagram base, or if it's working in a list base, or if it's working in a scripting base, whatever the developer itself decides and whatever the system will propose at a point in time. Okay. Now, all of that we have created, which is the end part of this, what we have created is a very, very big tree, if you put it that way. Okay. It's a set of dependency layers between all the different ontologies. Dependencies at the layer of how it's defined and dependence at the layer of how it's redefined, which are two different things. One of them is what information do you hold? And the other one is what information can you hold? So how can you grow in that way? But it's a very big tree-like structure that allows any developer just to go in and create artifacts just by the definition of the artifact itself, which with the scalability that we've seen before, it has at its disposal like a dictionary, if you put it that way, of 100,000 plus elements that can be recombined to execute in a transversal way any enterprise level structure. Okay. So, well, to finish, a couple takeaways. Well, is first, we consider at the end of the day that coding as a matter of getting text and writing it down is something that within the years should, I don't know if disappear, but narrow down a lot. And that the modeling, modeling structures, definitions, no matter if there are diagrams, scripts, tables, it doesn't matter how do you model, but at the end of the day, how you define in the modeling perspective, it's how to overcome big level environments. So environments where you have thousands or tens of thousands of ontologies are almost unacceptable from the developer perspective because they're too complex to be able to manage in reality. Okay? The second is that as Locomote is doing at some point, but in reality, we should all invest, or the questions that were done to the previous participant, we should all invest in interoperability of models as to how to define in a generic way what is a model, and then being able to transfer those payloads between systems. That is something that has to be worked, and we all, from the maybe private sector and public sector combined, should work to be able to have one standard structure, or at least one ability to do it. And finally, the enterprise, every day in the enterprise level, everything is growing, its complexity is growing in an exponential way. coding and the coding alike structures are actually fall short into the evolution of the software. Because we need to consider that the most important part of development is not from when we have nothing to when we go into production. That is the simplest process of all the development part. Then it becomes ever more complex in every roundabout that we keep on going as to we want to add more and more and more and more functionality, which is how companies work at the end of the day, is they start with a little piece and they keep on growing, growing, growing. That growth process is the most complex part of all of it. And it's an exponential complexity problem, which at some point is unachievable or impossible to actually accomplish. Okay. So, well, this is all. I'm over time. So thank you very much to all. And well, if anyone has any questions.
Thank you, Pablo. Thanks for the interesting talk. Many insights about the sizes and complexities within your domain. Is there any question you would like to ask? Right, maybe I can start while questions pop up. I'm always, I have to confess, whenever I hear ontology, I'm always a little bit puzzled. Like what exactly do you mean here? So is it that you use some standard for ontologies like OWL or RDF schemas, or do you use your own format? And is it that you use the typical reasoning services for ontologies? So in short, how your ontologies would be different from models?
In reality, so if you consider the old standard for ontology, there is not so much difference as to the information that you will input into it. Because the importance is, in that case, is to how do you create an environment that will grow as to more and more and more information on the ontology without going to the external code problem. So we can consider in this case the ontology on the base or on the core or on the definition of it as the old ontology or the old definition or the old standard for the ontology. We actually have integration with it. So it would be a correct idea. And then the extra information that you will need. So the extra part is all the other side that goes into, well, maybe forms, definition, actor, security, that kind of information that is normally not considered within the basic structure, but it's completely necessary when you are growing or expanding the definitions or the semantic of the environment itself.
Right. Yeah, see, so it's similar to the OMG's meta-modeling levels, where you have some core meta-modeling language at the top, like eCore or something like that, and then everything is defined in terms of that language, but you don't need to go outside to add new stuff, right?
Correct. What we created on that one, on the problem of adding things from the outside, is that we always propose that going to external language, external coding, it's something that is not good for the evolution of the environment itself. So if you have 80% of your environment modeled in whatever technology, and it doesn't matter, and then you have to program in some external Visual Basic, C# or something, the end of the definition of the functionality that you want to apply to your modeled elements, that is inefficient on the long term. So what we define is a way of expanding the definitions so you don't need to go outside.
Right. And also, yeah, I was amazed to see now that you have everything explicit, no? So everything is defined, specified in terms of your ontologies and so on. So to see the high amount of ontologies that your clients have built and so on. So do you profit from all this information? Do you dig into what is there to find patterns, to recommend the developers different ways to organize their models, or do you have intention to do that? Because to my mind, that would be very interesting to really analyze all those ontologies to, for example, to build recommender systems.
We've been trying to build one. Well, building a recommender system, it's highly complex. It's one of the problems. One of our research lines during the last year and some part of this one was working into the what we call the next step in navigation problem. So instead of building the navigation system, so when you click accept, where do you go? Instead of doing it by hand, building a recommendation system that will propose you where should you go or where could you go. We've been working on that direction, and we have also been working in finding patterns in security access to the information. So there is one of the obvious security elements that of profiling, who can access what. But there is other ones, that is who accesses what normally. So the filtering and the order of the access points and the graph of ordering the information is actually settled by a recommendation system. We're working in those two right now. And but yes, we have in that case, we have vast amount of information for anyone that may have an idea of where we should test this. We'll be more than happy from the research part to
yeah, certainly, because you see within the project there are several students, several ESRs that are working on mining model repositories to extract patterns and recommendations, and also on building recommender systems. And for that, you need a lot of data. So certainly that would be
we would have no problem to sit down with a particular ESRs and giving them access and explaining how the structure works, so they can do data mining on it or any other. Absolutely no issue.
Yeah, I think Massimo has another question.
Yes. Well, first of all, thank you for the presentation. It was very inspiring. So your approach based on ontology is really interesting. On the other side, I also appreciated that you highlighted this need for interoperability, for portability with other tools and environments. Do you have any insight about, of course, this is future work and there is research to do, but do you have an insight about how this could happen for an ontology-based approach like yours?
Well,
it's a difficult question because
it is. I'm thinking of so. Now, there are levels of interoperability in the modeling world that they are already there. So the obvious parts of BPM, DMN, and CMN, and those kinds of structures, they already have standards, and those standards are mostly interoperable, okay? Then you have another group of elements that are normally not so much considered, but they are very well interoperable, that they are data structures, okay? So the core definition of what data are you going to manage, and how are you going to manage it? So, namely tables, indices, index, or single table structures, Cassandra or HANA type, that kind of elements are actually very portable. You can send the definition from one to the other. Now, we do have a microlanguage, no, a DSL, sorry, my fault. The translation was wrong on that case. We have a DSL to define user interfaces and forms that is actually, it will be published in open in not so much time. We're working on that. That is how to define the visual structure of the data that you want to input. I think if the problem there to start with, to that issue, is we not all consider the same elements. So I think if we at least can all agree in a form has tabs and elements, then we will create an interoperable structure. That would be the simple element. But I have ideas of how to approach it, but I don't have any definitive we should go in this path, because I do feel it's very, very, very complex. It's one of the most complex elements, I think it is. Right?
So something like standardizing the conceptual level and then having a way to map it both to your ontologies and to, for instance, meta models for other tools.
Yeah.
Okay, thank you.
Thank you, Massimo.
Thank you. Any other comment? According to the plan, we would have 10 more minutes of additional discussions where, if we want, we can ask questions to the other to the previous speakers as well, if they are around. I think they are. So, for example, for me, it was comparing your approach to the previous approach explained by GenMind model. In GenMind model, I believe they are based mostly on code generation services, while in your approach is purely interpretive. Is it correct?
Yes. We work on. We have developed a set of interpreters. Sorry. That will get the definition of those ontologies and elements that we worked before, and then they will be execute them on real time, obviously. And I do think in reality that well, obviously the interpretation. So you have to decide where do you have to lose power, because if you go towards code generator, you end up with 100% of the structure, and you can expand it because at the end of the day you have source code, and the source code is expandable. Now, if you work with interpretation, you need to understand or accept, depends how it looks, that the interpretation element can be, so it has a set of options, and that's a closed set of options. You cannot open that. Now, we have worked, and we keep on working in expanding the interpretation levels. And what we've done on that case to not have a bottleneck, because that would be a very natural bottleneck, is to include different types of interpretation, and that you can actually do models that behave itself as interpretations. Like, to put an example, interpreters, sorry. To put an example, BPM. In BPM, what we developed when we did the BPM and the typical diagram and all of that to be able to develop a BPM, which extracts in a standard, and then you can input it somewhere else. Well, that interpreter, complicated word, of BPM is actually developed as a model itself. So you can keep on adding functionality and procedures to the interpretation as simple as you do in the other places. That is the part of the recursiveness of the environment that allows the expansion or the scalability of it to be, well, exponential to some point.
All right, any other comment? Then, but if not, perhaps if we don't want to discuss anymore, maybe we can stop here. It has been a long morning, quite interesting and exciting, I would say. Thanks a lot, Pablo, and thanks a lot to the other speakers. I think we got a very good idea of building blocks for low-code on specific examples for low-code platforms. And I would suggest to have a break now for lunch, and then come back at, I think it was 2:30? Yes, it was 2:30, where we'll have three more presentations, this time from academia, where we will have a look at techniques that we can also use to create scalable low-code platforms. All right, so I don't know how should we proceed, whether we should leave Zoom, or maybe Surur has a clearer idea. We should cut the YouTube transmission, or what's the...
We cannot pause the live stream, so I can have it. I mean, I can share a screen and have a background.
All right, yeah. Could work, yeah. I mean, we all can leave the Zoom meeting, right?
Yeah.
Will be active.
I will keep it.
Okay, perfect. See you later.
Yeah.
Thank you.
Bye.
See you later.
correct?
All right, so welcome to this afternoon session of this low-code workshop. This afternoon we have 3 exciting talks. In the morning we had talks by the industry. Now we have presentations by academics, and they will present interesting methods and techniques and experiences on different scalability issues and aspects that could be integrated in low-code development environments. So the first talk will be by Antonio Garmendia from the University of Linz in Austria, and the title will be Design of Scalable Domain-Specific Modeling Languages. As a reminder, the talks are about 40 minutes, so one idea is to have 30 minutes for the presentation and then 10 minutes for questions. You can ask your questions if you are here in the Zoom meeting. Please use the chat, or even better, use your mic. If you are watching this from YouTube, you can use the YouTube chat, and in any case, you can also use Twitter. So maybe, Antonio, if you can try to share your screen.
Yes, working on it. Yeah, so yeah, you can see my screen, right? Let's see. Yeah, thank you, Juan. May I start?
Yes.
Ah, great. So, welcome everyone. Thanks, Juan, for the introductions. Indeed, I'm working now with the JKU Clearplace University. Thanks to everyone for attending to this talk, which is about the design of a scalable domain-specific modeling languages. So, in this talk, I will start with an introduction to model-driven engineering, specifically the challenge when designing domain-specific modeling languages. After this, I'm going to explain the approach that we decided to design those languages in the modularity way. And after this, and the creation of the graphical concrete syntax in DSML. After this, the application of this approach with some case studies, and finally some summary of the talk. So model-driven engineering basically promotes a model-centric approach for software development. So therefore, models plays an essential role in the MDE. So in the MDE, basically, we have two principles. The first one is to increase the abstraction and increase the abstraction. We do this creating the domain-specific modeling languages in which we isolate the developers from the complexity and reduce the effort in developing a certain application. And the second principle is to increase in the automation, in the sense that we have those creating models using the domain-specific modeling languages and to immediately generate code from for a specific platform. So how we usually create these domain-specific modeling languages. So the creation of these DSMLs are recruited in MDE, and usually we create an abstract syntax, concrete syntax, and the semantics. Usually to describe an abstract syntax, we describe it using a meta model. So this is a meta model for an excerpt of a telecommunication. We say that meta model has a class home and includes a one cable model. And we should create models that conform to this meta model, say like home, and have the scalable model with this IP.
And to create these models, usually we design a suitable modeling environment, which is to have a canvas and a palette to facilitate the creation of elements and the relation between them. So, but there exist some challenges when designing those environments. So, for instance, those environments are characterized by the use of monolithic models. So, in practice, in MDE, the construction of monolithic models may become large and wide, and when that kind of things happen, so the tools they become it would be very difficult for the tools to process those kind of models. So we have an approach which is a pattern-based approach for this language modularity. So the other challenge is regarding the graphical editors. Usually building modeling editor is expensive, and since they must adapt to the particularity of the modeling language, so for which the editor is defined. So building of graphical languages is particularly challenges if the construction typically requires deep knowledge of the language development framework. So then we would like to isolate the developers of this complexity, and also we would like to fragment, of course, the concrete system in the sense that we can improve the scalability and the separation of concerns. So in this sense, we have an approach which is a systematic engineering of graphical modeling environment. So let's start by an approach for the language modularity. In this sense, I'm going to propose this pattern-based approach, first identifying some requirements that a scalable modeling environment should have, an approach to build those environments, and based on the requirements, we design the base of patterns we mentioned that the catalog of modularity patterns to fulfill those requirements. And after that, I'm going to propose our tool, which is we called it EMF splitter. So from our point of view, a scalable modeling environment to have several characteristics, in the sense that the first one is the ability to define fragmentation strategy for models, in the sense that we don't have all our models or our objects in just one model, just to try to enforce the separation of concern in order to improve the performance, in the sense that our tools doesn't have to load all the objects, all the model at the same time, just basically it would be enough for a part of it. So also the ability of organize the model content hierarchical. So in the sense that we have our models separated by packages, folders, and try to improve the usability. The third one is the ability to control the visibility of elements. Now that we have our element fragmented, split it through the file system, we'd like to define the visibility of those objects. So it's like basically in programming language, we define that one object is public or private. And also the scope of the cross references, in the sense that when I'm going to would like to find a candidate object, then just define in which are the objects that are candidate for to reference with. And the fourth thing is to try to the ability to customize the scope of the theoretic constraints. So usually when you have a meta model, you attach OCL constraints and to for validate those models. So basically, we would like to scope this in theoretic constraint because we have now our model splitted. So maybe the constraints doesn't need to load the entire model to execute the constraints. So try to design to improve the performance. And finally, the ability to define model indices. So we will have like a backend, maybe SQL database or NoSQL database, in which we have some indices to so that we can improve the constraint execution. So our approach to build these modeling environments is the process is basically in this figure. It shows our approach to design these scalable environments. So this approach provides a catalog of patterns that we can define these patterns at the meta model level. We can define this as many patterns as we like, and with the information of this pattern, we can generate automatically a modeling environment in which the users can create model in a fragmented way. So how we can define the pattern at the meta model level? So in this sense, we're going to use a synthetic example that basically a pattern is like a meta model. And the classes, the reference and attributes are called roles, and each roles can have a cardinality. So the cardinality rules how many times the roles can occur in a pattern application. So to simplify this, we have this pattern that has two class roles and one attribute role and one configuration role and this reference role. So this role doesn't have the cardinality, so we suppose that this we can instantiate it just one to one. And the other one, this class role and this reference, we can instantiate it one to many. So we can instantiate a pattern using this domain meta model, and this is the pattern instantiated. We instantiate the role A one time, so we can just instantiate one because it has no cardinality. And we can instantiate the role B just two times, just with class B and with class B1 and B2. And the result is in this figure, in the sense that our class B is role B, this class B2 is role B also the reference as role ref, and I give it as this attribute configuration a value, which is val. So throughout this presentation, I'm going to use this example of wind turbines. That was one of the case studies we worked on in the European project called Mondo. This language defines a class of WT components which include a set of subsystems. So this set of subsystems, we can define different components. Basically, we can define the input and output that we can connect it using a connector, and a control subsystem can define different kind of state machines. Right? We can connect components to state machines also with these different states. So how we define our model fragmentation pattern. So the fragmentation strategy should be specified at the meta model level, where the different classes can be titled as project, package, and unit. So we take inspiration from the modularity concept of languages like Java and its Java development tools, JDT. So similar to JDT, we are able to select a class that's going to be the project, and the project is going to be the root in which we can contain the rest of the elements, which can be any of the other types, package and units. So inside the package, you can contain objects of type package directly, and you can contain units as well. So in the units can be defined either inside the package or directly inside the project. And the units are going to group all the related, basically all the related elements. So how we apply this this model fragmentation to this WT components meta model. So this is a fragmentation pattern defined as a meta model. So we should define at least one project and one unit, and it is optional to define to find a class as a package. So in this WT component, we define the WT component class is a project, and we define two packages and two units. The package system, you have different files that are going to be the architecture, and the package control systems, which is a class that's going to have several files of state machines. We also define some values like the icon and the extension for the unit. So based on this model fragmentation, now we define the reference scoping pattern. The reference scoping pattern basically is for define the set where when you have the reference for class A and class B, we would like to get as a result the objects that are going to be candidate to be references. So for doing this, we created this scoping pattern and with different type of scoping. Like you can say that I'm going to search the object in the same workspace, the same project, the same root package, the same package, and in the same unit also. So in this example, we used also the WT meta model. We applied the scoped class to component. I'm going to say that I'm going only to be able to reference state machines that are in the same package. So the effect of the pattern application is that when I have this file, this architecture, I'm going to be able to reference this state machine because it's in the same package, but I'm going to be able to select this as MD2 state machine. Okay, so the other pattern that we define is the visibility pattern, which allows which subset of elements to expose to other fragments. So in this sense, we can attach this visibility pattern to any class, and we can say that they define also the scope and also an OCL constraints, in the sense that we define the visibility for workspace, for project, for root, and for package. In this example, we say that the scoped class component, we also apply this to component and the reference state. And now we say that the visibility is going to see that the same package that the is public should be true and don't start with the underscore the name. So now the effect of the pattern is like I'm not going to be able to reference this object because this name starts with 2 underscores, right? Because this element is not visible. So the other pattern is the indexing pattern, and this pattern is basically to speed up the computation of query by creating indices. So usually you have a relation between the constraints that you have attached to your meta model and the indices. So in this case, this is the meta model from the indexing pattern, and you can instantiate it to any class and instantiate it to any attribute. Right? In this case, we use also a state machine, and we instantiated, we indexed the m name with a string. Also, it would be very beneficial if you use this these constraints. Okay, so the other pattern that we have is the scoped validation pattern. And this says that we usually have our meta model and OCL constraints that are usually evaluated on monolithic models. But now that we have our meta model fragmented, it is natural to incorporate the notion of the scope. So in this sense, we can apply this this constraint class, and we should define the name, the statement as an OCL expression, and we can get also an error statement to give some feedback to the user. So we can define the scope. Of course, this is also based on the fragmentation pattern. And we say that we can execute a constraint in the same workspace because if it's a global, so it's a time-consuming constraint, so we need the whole workspace or the whole project, the same root package, the same package, or maybe these constraints only need to be executed in the same unit. It would be very beneficial for us because we didn't need to load the whole model. So this is the constraints that we applied for the import class. And yes, we define like the name, the statement, and we say that the scope will be the same package. Okay. So for the scope validation, we define 2 scenarios, which is the incremental and full validation scenario. So the full validation is very useful because probably you are loading basically the first time your project, and you need to, for instance, to execute all the constraints to validate if this project is correct. But sometimes you are working on the project and you're working with the file or even with the package. So you need to load all the models to get a good to execute in a good way your constraints. So you're working is this F1 file. So probably these constraints are going to execute it in the package, but there is no need to load this other package to see if this whole model is correct. Okay, so all of these patterns and the modularity pattern are included in this tool that we call it EMF splitter. And basically this tool, but it has some a set of wizards in the sense that you can define those patterns very easily. And in this example, we say that we select this modularity pattern for WT meta model. Say that in the first view, you have to select the root of the root project, and in the second page of this wizard, you can select also which class is going to be the package and which classes are going to be the unit, and to fulfill also the other information that your icon or your extension. So when you use this wizard, what you get is an environment in which you basic on EMF in Eclipse, that in EMF you by default has these 3 editors, and you start creating your model in the fragmented way. Right? So now it would be desirable to have attached to this environment a graphical environment for model creation, in the sense that you have several editors to help the user to create these elements. So for doing this, we have this. We're going to talk now about how to define the graphical concrete systems, and we're going to propose some heuristics to assist in the graphical concrete systems creation and a read-only representation style for collections. After this, we see how we can combine this graphical representation with the fragmented model and the tool support we're going to present also that we call EMF stencil, that is compatible with the EMF splitter. So usually when you define your meta model and you would like to have your graphical concrete system, you decide this is an ad hoc process in which you have your meta model and you create a map between the classes and shapes or icons, graphical elements. Like in this sense, we have like a state machine. This is a square. Initial state is a circle with black background. Simple state and the edge is an arrow. So we create this graphical editor that we're going to create models that are conforms to this meta model. So what we're going to propose here is in this ad hoc process, the use of heuristic and the read-only representation style for collections. So to do this, we create an intermediate meta model to represent the graphical concrete system in a neutral form. So we call this meta model graphic representation. And this meta model basically supports the creation of layers, the creation of graphical elements, is node-like or edge-like. You can also define spatial relations, say that one element contains an other element, or an overlapping, which means that the element should be very close in the border of another element. And also you can create a representation style for collection, which basically resembles statements of general purpose languages. So we propose a set of heuristic in the sense that when we have our meta model and create our concrete system, we first start with the root. The root basically is the canvas. It's going to represent the canvas in which we're going to insert the rest of the elements. So one of the root strategy it would be to select the class that contains more classes, and also the class that contains with no parents. That would be because it makes sense that we have a class that are going to contain the rest of the elements. It doesn't make sense that you have some elements that are outside of your model. And the other strategy is to use it with the modularity pattern. If we know that there's a modularity pattern instantiated, we're going to say that we're going to create a visualization for each unit, due to the units are the ones to group the rest of the elements. So the other strategy is to use arc strategy, which we have two strategies: the simple direction strategy, in which we select, we have the class, and if this class has exactly two references 0 to 1 that are not contained, so we'd say that this is an arc class. And also we can basically select the arc class based on the parameter direction arc strategy. because usually we use naming convention like source, target, and we can use this naming convention to automatically define these references. So the other strategy is the label selection. And we say that usually you have an object and you put in a name. We say that we can select the first string attribute of this class. We say that we can select the identifier of the class. Say that you have a class that have an ID, or we can say we just also parameter in string attribute. That is basically we get benefit for the naming convention because usually you put name as an attribute of ID, so we can use this information to automatically select this label. The other strategy are the container reference representation, because we say that if we have a class that contains another class, we say that it is an affixed, or maybe it could be like a compartment class, or maybe you want to select it as a link. And the last heuristic is the graphical style, which is basically divided by two. Say like you can select a shape, you can select an icon. So if you select like shape, you say like you can use the semiotic clarity, which is one of the principles of Moody that said that there should be a one-to-one correspondence between the classes and the graphical symbols, which makes sense. So, and you also can select the random. So, so finally, you can also get benefits with some services like to get an icon. We implemented the Pixabay and the Google, and we retrieve some icons based on a query that gets an icon based on the name of the class. So, as a complement to this heuristic, we propose a read-only representation style for collections, in the sense that we provide presentation for visualization of typical graph structures. And we identify 4 styles, like when you have a loop, when you have a tree, a condition, or a linked list. I'm going to explain that when you would like to have like a linked list, let's say that you have a class A that reference a class B, and what we would like to get is this representation, in which you get like a list of all elements, right? So you should have to tag this class A as a node type and this class B as a containment. And our framework is able to generate all this infrastructure that you can basically through a wizard can customize at your need. So how we can join this graphical fragmented model with our graphical representation? So by applying the fragmentation pattern for the creation of model, different files are created in the hierarchical structure. So that is mapped to the file system. So the fragmentation strategy relies on the use of cross-references by which objects can refer to other objects that are in other files. But these cross-references can be container references or cross-references, in the sense that in the WT components has a container reference to the Graphical system, and when I reference this component to this state machine is a cross-reference. So then using the mechanism of diagram can also be constructed in the fragmented way. So in this approach, the objects annotated with units are those that group all the elements, so in the same file. So we allow the creation of diagram for each of them. So this is the figure that we can be able to create a diagram for represent the state machines and also to represent the different components. So we created a tool that we call it EMF stencil. And EMF stencil basically has also wizards in which you can define and you can customize your graphical editor. Also have the creation of representation style, and in the second page you can define also the shape, the width, the color, and so on and so forth. So currently we support Sirius as a target platform. And this is an example of the of a running example of wind turbines. You have this editor for the creation of your state machines. It has this other editor for the creation of the component. So using our approach, we created other case studies. So for instance, we use it with GAIX. The GAIX is a neutral data format to represent the hierarchical structure of production systems. And also with Henshin, which is a tool to create in-place information. So if anyone are curious about it, you can, let's see. You can take a look to this GitHub repository, which is in my, that I have in my profile, and we create, this we share a couple of environment, a scalable environment like these guys, this Krala environment for the design of the structure and architectures and the cloud robotics, and this very cute example of my turbines, my storm robot editor. So, okay. So in this talk, I just presented a systematic approach to develop a scalable modeling environment and for DSMLs, and we introduced basically 5 patterns like model fragmentation, reference scoping, object visibility, indexing, and scope validation, and which the tool support EMF splitter. And we also present an approach to facilitate the generation of graphical editor, which we implement a set of heuristics and some read-only representation style calculation to assist the user in the creation of graphical editors. And we have our tool support, which is EMF space. So thank you so much for your attention. So if you have any questions.
Thank you, Antonio, for the nice talk. Is there any question you would like to ask Antonio?
Hi, Antonio. I have a question for you. This is Luca speaking.
Hi.
So my question is about your DSL for the graphical concrete syntax. Is also, I mean, my question is to know if it is also suitable for animation. I mean, to define animations on the models. And even more challenging question: have you ever thought about extending this DSL for dealing with 3D notation? So that you can deal with 3D geospatial constraints or visualization, because there are some domains where, for example, more advanced graphical concrete syntax can be very helpful. But so far as I know, the tool support graphical notations by Eclipse it's quite poor because it's 2D.
It's 2?
It's it has only two dimensions. It's not 3D.
It's only 2 dimension. Okay. Well, no, this is no support for 3D so far. We just support this tool using CViews. And yeah, that's basically what we support so far. So yeah. And in the sense, what you mean, animation is simulation?
For example, imagine that you have an executable model for debugging, and then you execute the model, and then you have, I mean, I don't know, red or green or yellow surroundings to the icon. That, I mean, change during the model execution. Can you support this execution?
No.
Define this kind of stuff.
No, I would say no.
Okay.
No, I would say no. I mean, we have some kind of, as far as I remember, what you have is you can define like it's not filter, is customize your figure. It depends on the few attributes. You can do that, yeah. But no more, I would say. I mean, in the sense that if an attribute is one, you can put the color like green. if the attribute is 2, you can put the color as blue. Yeah, you can do that with the wizard. Yeah, but I would say no more. No.
Okay. We have another question by Kurat on the chat. Kurat, would you like to ask, or I can read? But I can read it. Is the index pattern that you have mentioned specified by the user? I mean, selecting which fields to be indexed.
Yes, this pattern should be specified by the user. And what usually you will like is to have some integrity constraints that are related with your indices, in the sense that if you know that if you have a query that looks for a name or look for a certain attribute, maybe what you would like to have is an index in these attributes in order to retrieve those elements faster. Yes, there's no mechanism so far to extract information, for instance, for the integrity constraints in order to give to the user a definition of which indexes will be beneficial for the constraints. Yeah.
Yeah, that was my follow-up question. So would it be feasible to do that? We would need to do static analysis, no, of a given query or an operation that is going to be executed, right?
Yeah, it will be at least beneficial for users in the sense that you can have at least an approach of which attributes you are using most, and using this information of reading these constraints, you can get this this automation, yeah, of indices. Yeah.
Any other comment or question you would like to ask? Maybe I can ask you some other questions, perhaps in relation with other, with the topics of other ESRs that are listening, because you have explained one of your techniques is based on fragmentation, right? So you take a DSL meta model, you apply the pattern, and then the model is fragmented. But your main goal here is to be scalable for modeling, so that the user receives an editor that, out of the box, support these fragmentation strategies. So modeling is more scalable. But would this fragmentation have also benefits for the scalability, let's say, of the execution of model transformations, code generators, and so on? Do you think it would lead to more efficient execution of model transformations in some cases? Or would you need different strategies for fragmentation? What is your intuition here?
I would say so, that in the sense of model transformation, if we are able to define which elements have to change, and yeah, it will be possible just to transform the part of the elements that you change into your target model, right? And for large models, it will be beneficial because you don't need to transform the model again, just a part of the model that change, that you change. Yeah.
Yeah, exactly. So
it will be like.
Yeah. Sorry.
No, that it will be like a good research topic to continue with.
Yeah. So I guess you are envisioning here a kind of lazy loading only the fragment that is affected by the transformation, but also because you have fragmentation already, you could do perhaps the transformation in parallel or in a distributed way as well. No? So that could also.
Yeah. And you can also thinking that you can just say like for certain files, those are, for example, thinking of ATL, saying that for this file, those are the rules that apply to this file. and maybe we can convert, and there is no need to apply also the other rules because they are not necessary in this sense. Like the same approach that we use with the constraints probably can be used in with the execution of the rules. For example, the ATL. Yeah.
Mm-hmm. All right. Any other question? Yeah, we have one question by Jan. Maybe you would like to ask it.
Yeah. Can you hear me? Yeah. My question is,
how does that
fragmentation work out in practice? So when I
imagine that being used in
and I move one element from one
Sorry,
package
I cannot
to
hear
another.
you well.
Okay. Let me see whether my settings are all right. Okay. Is it better?
Now it's better.
Okay.
Yeah.
How does it work in practice with the fragmentation from a user's perspective? So if I move one element in series from one package to another package, and then according to your rules, some of the links may break because they refer to things in the old package. How does that work out in practice?
Yeah, in a moment we joined this tool with the tool that called it Concordance, and Concordance was the tool developed by the University of York by Dimitris. That basically you can have like a database, an H2 database, I would say, and you have all your references, indexes in this database. So what you will have is when you move an element to another folder or project or whatever, you're able to automatically adapt these cross references to the new, for example, location, right? In this sense, for example, this WT turbine, you have like, I don't know, this WT components, and you have a subsystem. And if you move subsystem from subsystem, at least the proxy cross references that are pointed to this folder, you can change it automatically if you move this file to another folder. I don't know if it makes sense to you.
Yeah, it does. Thank you.
All right. We have another question by Eugene. Eugene, would you like to ask it yourself, or shall I read it?
I can ask it. It's okay. Just a quick question on your thoughts to automatically generate perhaps a default graphical concrete syntax for any meta model, because from experience, especially with Eclipse tools, it is quite tedious to write these, to specify these concrete syntaxes. There's a lot of hooks you have to go through, and it really helps to start from example, especially for novice users with these technologies. So have you thought maybe to help the user by generating perhaps it recognizes, for example, you have a linked list. Well, it will generate something for the linked list for that part. It has, I don't know, a containment. It will generate something for the containment, something generic. So just a question like that.
Yeah, that was the idea when we decided the heuristics, in the sense that you can define or select or read the meta model information, and when you have, you know, the containment, you can say that it's a compartment visualization, and so on and so forth. So yeah, you can basically generate very basic default editor from scratch. Just given the next, you could get a new one. But it would be more difficult for, I would say, generate, for example, or to automate, for example, the read-only collections, right? The loop or the tree, and we only let it in these heuristics that you can customize a bit, and you can customize this heuristic, and you can get automatically this this editor. Yeah.
Cool. I'm afraid we would need to stop here. We don't have more time, but at the end of these 3 presentations, we have half an hour that we can spend for additional discussions. So thanks a lot, Antonio. Nice presentation.
Thank you
let's move to
for the invitation.
Let's move to Hugo Brunelier, who will be speaking about scalable model views over heterogeneous modeling technologies and resources.
So hello everybody, can you hear me well?
Yes.
And can you see my screen, my first slide?
Yes, we do.
Okay, and now can you still see it in full screen?
Yes.
Okay. So thanks a lot for your invitation. So my name is Hugo Brunelier. I'm a researcher in the Department of Automation, Production and Computer Science of the IMT Atlantic, an engineering school based in Nantes, which is also the school which is coordinating the Locomote project. So I've been invited to present today the latest work that we did on the topic of scalable model views by combining modeling resources coming from different types of resources and using different modeling technologies. So this is kind of a long-time research effort that we did in the team, in collaboration also with the group of Jordi Cabot in Spain, and more recently with the group of Dimitris Kolovos in New York. So today I'm going to give you an overview of this work. And as you will see at the end, actually this work, it's a kind of a long-term effort from our side. So just a bit of context. So as you know, when you're engineering complex systems, for instance, in the context of local development platform, but also using any kind of design and development platform, you usually have to deal with a lot of different models. These models, they can have different purposes. They can be modeled using different languages. They can vary a lot in terms of size and complexity. And they can be interrelated, and usually they are interrelated to each other, meaning that they are not made independently from each other. Thus, generally, you need to provide, or you need to have different kind of views that are combining these models all together, depending on the type of stakeholders of this system, whether this is the designer of the system or eventually the final user. So in order to do that, we propose to a model view approach, which is called EMF views. As indicated by its name, of course, this relies on the EMF framework and is proposed a way to build and handle views of heterogeneous sets of models. So I'm not going to give in this talk a very detailed description about the insights of EMF views, but I will give a couple of hints about how it works in some minutes. But just to say that it relies on a model virtualization framework and a proxy mechanism. And then that basically, as it relies on EMF, it already works quite well on models of reasonable size. What we wanted to do with this, the work I'm going to present today, is improve the scalability of the approach. And especially when we want to work on larger models and we want to work on models that comes from different types of data sources and that are using different kind of modeling technologies. So this is the focus of today's presentation. So what are the main contributions I'm going to describe in this presentation? So first of all, a conceptual approach for integrating together modeling technologies and model persistence solution with our model view framework. And we have realized this in practice in Eclipse by using, of course, our EMF view solution as the model view framework, by considering 2 different modeling technologies, EMF as the Eclipse standard modeling framework, and also Epsilon as an alternative way of handling models in Eclipse. And in terms of persistence solution, we have considered 2 of them so far. So NeoMF, which is a solution which provides multiple backends for storing and loading models, and CDO, which is the well-known Eclipse-based solution for storing models in databases. And finally, I will show that we have evaluated our approach and based on a small implementation that we realized in the context of a European project. So just a few words about this project, which actually provide the context of the example that we are going to use in this work. So the Megamart was a 3-year European project, which was kind of big in terms of partners. We finished the project some months ago, so earlier this year, but we managed to get interesting results. So one of the main objective of the project was to work on the traceability between runtime and design time models, with the idea of providing possible feedback loops from runtime information, models encapsulated in models such as logs execution traces, and so on. And we wanted to be able to go from this runtime information back to the original design models of the system. And in order to do that, in this project, we proposed to use the model views that would combine these different types of models all together, so that a user can actually navigate and query these views in a way to integrate all these models together. So just a few words about the concrete example that we are going to use. So this is an example view that we built in the project, which was kind of the motivation that we use for the scalability work. So as you can see, we combined 4 different kinds of models. So on the requirement model, a component model, a source code model, and a runtime model. Basically, the last one is a model that represents execution trace information. So for the requirement model, we use a standard CSV file, an Excel file, which was presenting the requirements in a standard way using CSV comma-separated values. Then for the component model, we use UML, basic way of dealing with components. For the source code model, so as the project we are working on was in Java, we used the Modisco Java meta model and the corresponding model discoverer to get the source code model. And finally, for the runtime log information, we simply use a custom train meta model that we defined specifically for this project. And the idea that we had was to have a view that would combine all together these 4 relating models. And then we would navigate this view so that we can go from the requirement model back to from the requirement model to the runtime information, and on the contrary, going from the runtime information back to the original requirements, passing by the different intermediate models. So how it looks in Eclipse. So here is just a small example of how the resulting view looks like in a model browser. So as you can see, it looks like all the information was actually inside the same model, but in fact, these are actually 4 different models connected together in a single view. So on the top, on the up part of the slide, you can see a trace log, which is actually coming from the runtime log model that is serialized actually in the database. And then we can transparently navigate this model to go back to the different models. So for instance, from the trace log, we now have a new relation to the corresponding Java class in the source code model. And then once we are in this Java class, we can navigate back to the component that correspond to this class from the UML model. And then finally, we can go back to the original requirements or sets of requirements that provoked the design of this component. And this is coming from the requirement model. So actually, you can see that thanks to such a view-based model view approach, we are able to navigate different models all together as if they were actually one single model. And this is totally transparent from the user perspective. So just a few hints about how EMA views allow this. So I'm not going to give all the technical details about the insights of EMA views, because the topic of today is more about the integration of EMA views with different other modeling solutions. But still, in order for you to be able to allow what's happening under the cover, I will just explain what is the virtualization mechanism about. So as you can see here, we have 2 different levels. On the up part of the picture, you can see the meta model level, in which you can define viewpoints. And on the bottom, you have the model level on which you can define corresponding views. So basically, the main idea of EMA views is that from a given specification of a viewpoint view that you can provide using an SQL-like DSL that we provide with the tool, the framework is able to automatically compute a viewpoint that will combine all together the different meta models without copying them, without duplicating information, just by providing proxies to the original elements in a way that this is totally transparent to the user, so that you can obtain a viewpoint as a virtual meta model and a view as a virtual model. The view specific information is actually stored separately as a reading model. All the rest stays in the original models and meta models. So there is here no duplication of elements. So this was just to have get a general impression of how EMF views work. So actually, as I said before, the main topic of this presentation is rather on the integration approach that we propose. So as I said, the idea was to combine model view framework with different modeling technologies and with different persistent solutions. So what we propose is that to put the model view framework at the core of the approach in a way that it allows to be completely integrated with a model-based tool solution that we have on existing technologies. So you can see here that the model view framework implements the generic interfaces provided by the different modeling technologies. So that is the strong parent from the user perspective. And then it knows how and when to delegate appropriately, how and when to delegate appropriately the corresponding query execution parts to the different modeling technologies and the corresponding persistence layers. So what happens here, for instance, you can see the bullet one when the architects define the viewpoint, the view specification, then the model view is able to compute this view. This is the bullet number 2. And then once the view is computed, you can actually query it. So if you have an engineer that defines a query, whatever the query is, using his own model-based tool, querying tool, then this query will be defined using his usual modeling technology. And then this is totally transparent to him what's happening under the cover. So the model view framework will take this query by using the generic interfaces of the modeling technologies. It will interpret this query, it will dispatch appropriately the different parts of the query to the different modeling technologies, and then to the different persistence layers that this modeling technology is actually supporting. An interesting aspect also that we proposed as a complementary to this automated query execution dispatch mechanism is the fact that we also allow to perform some specialized optimization for some specific persistence backends. So that's why you can see on the left part and right part of the screen this bypass arrow that in some cases allows to directly benefit from some optimization that are present at the backend levels. So if we apply this in terms of with concrete tools and on our concrete example, so here you can see the same figure but with actual tools behind it. So of course the model view framework that we use, it's EMF views, as you can imagine. So as a core modeling technology, we use EMF that you can see on the left side of the screen. And then we also integrate the use of epsilon as an alternative modeling technology. And in order to do that, we had to implement a specific EMF views model view connector for epsilon so that epsilon knows and how to use the EMF views models appropriately. So that's one thing. Another thing I wanted to mention is that thanks to the use of these existing modeling technologies, we are benefiting from the persistence solution that comes with them. So for instance, with VMF, of course, you have the standard XMI, XML implementation. For the epsilon, you have the solutions such as the CSV connector that is coming for free. We implemented this time a specific new EMF graph database connector. And also on the other side, on the Eclipse side, we are using CDO. So at the end, we are using 4 different types of connectors for the 4 different models that we have seen in our example. So some challenges that we had to face in order to realize that in practice. So of course, we had to refine our model view framework, which was initially made to work only with EMF. So we had to refine it so that it now supports different types of modeling resources using different modeling technologies. So now that we have done this for 2 different technologies, it can be potentially done for other modeling technologies in the future. We have also made an effort to persist and manage the view-specific information, the model weaving I talked to you a bit earlier, in a scalable way. And in order to do that, we also benefited from the backend solution that are provided by the different model persistence solutions. We had also provided load views and access corresponding model views with an acceptably low overhead. So this I'm going to show you in more details with the experiments that we have performed. Basically, the idea was that the overhead of using a view framework has to be as limited as possible so that it's not, it does not prevent the user from actually using such a view solution. And the same happened when we create a model. We had to make an effort notably in terms of optimization, so that the query of the model view stays efficient. So just a small example on the query optimization to see how it works a bit more concretely. So here, this is an example of a simple query that we can define on our example view. So we just take all the instances of the log model, and from these instances, we select the one which starts with a particular message. And once we have this, then we are able to navigate back to the corresponding class, and then back to the corresponding components, and then to the sets of requirements. And we compute the number of requirements that corresponds to this given log. So these actually correspond to the same type of navigation that we did in the model browser, initially in the slide I showed you before, but this time using an OCL query. And as I said before, what happens when such a query is triggered is that the model view framework is able to dispatch different parts of the queries to the different underlying modeling technologies. And of course, you can see, as I said before, on the right side, this bypass mechanism that we implemented. So for instance, here we implemented an optimization, a specific optimization for the all instances operation, as it's a costly one. So here you can see that we are able to bypass when needed the modeling technology. So how it behaves in terms of performances, all these approach and these different layers. So in order to measure this, we have made experiments that are fully detailed on a paper. I'm going to point to you after that, but just to give you some general information without giving too much details. So we did 2 versions of the same view for this experiment. So the same view is still the view that I introduced before. So we had two examples. One is fully file-based, so just standard EMF XMI models. And another is the view as we want actually to deal with it. So the mix of file and database resources. So as I said before, the requirement model, which is a CSV file, has been handled via Epsilon. The UML component model, which is a standard EMF XMI file, has been handled via EMF, of course. The Java source code model has been handled in a relational database by CDO using EMF. And the runtime model, which is the largest model, the one that contains the execution traces of the system, has been handled as a graph database using EOMF and via Epsilon. So here you see that in this view, you really have 2 different modeling technologies and 4 different kinds of persistent solutions that are combined all together in one single view. And the idea was to perform complementary benchmark on this example view, so that we can measure the view loading, the view loading time, the time for performing a full iteration of the view, and the time to perform the queries on the view, notably the queries that you have seen before. And for each one of these 3 benchmarks, we perform measurements on model size going from 10 elements to 1 million elements. And thanks to that, we have been able to see how our integration approach reacts when the models get bigger and bigger. So as a summary of the experiments, I'm just going to give you some quick insights about what we have observed. So first, concerning the view loading. So as expected, we have seen that the heterogeneous version of the view is slower than the XMI one, which is expected because, of course, you have different kind of database accesses to be made. But what is interesting is that we wanted to keep the overhead in a limited factor, what we managed to do when the models gets bigger. So we have observed this interesting behavior is that when the bigger the model gets, the smaller the overhead factor is, which is a kind of encouraging result, I would say, concerning the view loading. And we also have to consider that the view loading is not something that you perform many times usually. So once the view is loaded once, then of course you don't have to load it several times in order to query it or to do manipulation on it. So this is also the important parameter to take into account. Once the view was loaded, we also computed the time to perform the full iteration over the view. So here we have observed that there is not so much difference between the heterogeneous version and the full XMI version, which is kind of a satisfactory result. We have observed overhead factors that goes from 1 to 3 for the bigger models, which is relatively acceptable. So I think this is a pretty interesting result. And the last sets of experiments we performed, which was about view querying. So here we have observed that the heterogeneous view, the base heterogeneous view is globally slightly slower than XMI1, apart from when the models get big. And in order to remediate to this issue, when the models get big, we perform this specific backend optimization, the bypass that I showed you before, which allowed to obtain improvement from time to 300 times, which is kind of interesting as well. Some general lessons we have learned. So as I said before, using a standard API, modeling API, such as the one of EMF or Epsilon, if we also consider it as a standard API, it's really a good point because this allows to facilitate the integration with other solutions. But of course, it has to be done with some caution because sometimes this can hide some lower level optimization. And this is notably why we had to implement this backend specific optimization that were some kind of hidden by the modeling frameworks. So this is what we did for the all instances operation. This corresponds to the second bullet, and this requires some effort. This does not come for free. And the last point I wanted to mention is that we had to deal with multiple development environments and multiple technologies, which is also an additional factor of complexity, but still this is something that that's interesting to do and that facilitate later reproducibility and portability of the approach. So that was all for the experiment themselves. Just a few words on the related work. So as you imagine, EMA views is not the only model view approaches existing. Actually, there is a quite significant number of them. If you are interested on the topic of model views in general, I encourage you to take a look to this paper I put the reference here, which is a systematic mapping study that we did on the existing model view approaches, and that provide a taxonomy with a set of features and how these different tools match these different features. And what we have observed generally is that there are not so many proof of the scalability of the model view approaches, and this is notably what triggered this idea of this work. We have seen that there are few approaches that integrates models from different sources that allow to do that. But if they do, they have other types of limitation, notably in terms of scalability as far as querying is concerned. So this was also one of the main motivation for the work that I presented. Apart from pure model view solution, there are also other types of techniques that are sometimes used to emulate model views, such as model composition or model decoration. But these solutions, they also have some limited optimizations for specific backends. And this is also one of the drawbacks that we wanted to overcome with the solution that we proposed. So this was for the model view part. About the querying aspects. So of course, there is a community working on this, and there are many interesting results already existing, notably in terms of incrementality. Also in the data warehouse community, there are many things around the querying optimization and so on. So these are all possible extension of our approach and things that we would like to play with in the future. So coming to the future work. So there are still many things that can be done around the EMA views itself and around this integration approach. So one thing that I've just mentioned is the use of incrementality. So far we just considered the basic querying using the standard OCL implementation, for instance. We have not tried to evaluate the performances of the solution when you perform multiple query execution over the same view. And this is a scenario in which we think the integration of incremental capabilities could be very useful. So this is one aspect. Another aspect is the improvement of the compatibility of our approach or the scalability of our approach with model transformation techniques. So here I mean model-to-model transformation, but also code generation. We have already tried perform experiments on our view solution with ATL, for instance, or with Axeleo. So we know that we are already able, taking a model view as input, we are already able to transform it to another type of model, or we're already able to generate code from it. But we would like to see if we can go further and optimize this the transformation computation by partially delegating parts of it to the different persistent backends, for instance, such as we did for the querying part. Another aspect that is something that is very important when you talk about views in the database community, for instance, is the support for view update or view maintenance, meaning the synchronization from the models to the view and from the view to the models. So here we think that the fact that we want to deal with, that we're actually dealing with different kinds of technologies and different kinds of resources adds an extra level of complexity to a problem that is already kind of complex. So this is, I think there are still many things that can be done in this area, and these are interesting possibilities for the future. And finally, and this is something I highlighted in this slide in particular, because I think this is kind of relevant to the topic of today, is the fact that we would like to apply views and this integration approach in different projects and use cases, and notably projects in which we would add new data sources, for instance, cloud-based one. So I think Philip this morning did an interesting presentation about the type of capabilities that from which we could benefit. And I think these are the kind of things that we could try to integrate in our approach. It would also be interesting in targeting different types of users. So currently, the view approach that we provide works at the abstract syntax level mostly, meaning that we don't support the combination of different concrete syntaxes, whether they are textual or graphical. And I think here there are many things that can be done to this respect. So that was all for the future work. Just a few words before finishing on the bibliography that correspond to the work that you have seen today. So the first paper, the sourcing paper, is actually the paper from which most of the content of today's presentation is coming from. In this paper, you will also find all the details on the different experimentation that we have performed with all the tables and figures. So if you are interested to get more details about this, I encourage you to look to this paper. The second one is another experiment we made with EMF views, but this time we integrated the tool with a traceability tool called GTL. So this is just another example of integration that I did not mention today, but still that's interesting to see. The last one from this slide is the survey that I talked to you before. So the survey of model view approaches that we did. That is also an interesting source of information if you are interested in model view approaches. And the other one are all the papers that we did and that were more focusing on the insights of EMF views. So if you're interested in EMF views itself and not only in the integration approach in general, please you go and take a look to these various papers. So that was all from my side. I think in terms of timing, I'm more or less on time, maybe a bit earlier. So if you're interested by seeing a demo of the tool, if the tool is not very graphical, because of course most of the things happen behind the scene, but in the context of Megamart, we recorded a demo which shows how we can build the views, and then from this view how you can generate automatically some kind of report, dynamic reports. So if you want to see how it looks in practice, here I put the link to this short demo. Of course, the tool and all the resources, the source code of the tool, but also the benchmark that we did in this scalability evaluation, everything is available online with the manual, tutorials, and so on. So please, if you're interested in the tool, go to the website. And of course, if you have any question about EMF views itself or about model views in general, feel free to contact me at this email address. So that was all for me. Thanks for your attention. And if you have any question, I will be happy to try to answer.
Thanks, many thanks for the interesting talk. Really useful, I think, in the context of this project. Is there any question you would like to ask people? Kurat has a question. Maybe you can ask using the mic.
Yes, it's Kuratulain here. So in the bypass process that you mentioned, are you using query translation to native query language for getting benefits of specific optimizations? And if yes, is it performed at runtime?
So no, we don't actually transform there is no actual query transformation at this stage. This is something that has been studied at some point, but it was kind of more complex to what what we did. So we decided to go for a more straightforward approach. So here, when I mentioned the bypass, it means that we actually made a call to a specific implementation of this of a given operation. So for instance, there is a NeoMF, the NeoMF solution here, that is used for the runtime log models. It comes with a specific implementation of the all instance operation that is optimized for graph databases. And instead of going through the regular all instances operation that is provided here by Epsilon, or could be the same by EMF, we just call directly here the specific implementation, optimized implementation provided by NeoMF. So this is what the bypass is about. So there is no, at this point, we didn't perform any query or parts of query transformation for the optimization. But this is something that could be envisioned for the future. So far, we are just dispatching the different parts of the query without actually transforming, optimizing the query itself.
All right, thank you.
Any other question? So in the meantime, I have a couple of curiosities. So is the view approach dynamic? I mean, whenever some of the sources here at the bottom, the model or the requirement model changes, does the view get updated dynamically?
So as I said, we are not going very far in terms of view updates currently. So it's updated, it's partially updated in the sense that as we rely on a proxy mechanism, so we don't duplicate the original model elements. So for instance, if in the view, one of the original model, there is the value of a given attribute that is modified, then this will be visible also in the view. Because of course, as we just point to the original elements, we don't copy it. So this kind of a small update will be automatically visible in the view. But if you imagine more complex modification in the original model, such as the addition of new elements, for instance, or new relation, so in this case, this will not be automatically updated in the view. You will have to recompute the full view to get this modification visible in the current implementation. So that's why I mentioned that we still need to work on this, on a better update mechanism for EMF views.
Any other comment? All right. Well, in the meantime, whenever I have views, I hear views, I have a different, almost the opposite of what you presented, no? Because here you have a scattered information, like in from different sources, and then by means of a query, then you build out a virtual view on top. But in other approaches to view definition, you do the other way around. You start from a single underlying model, maybe it's a big model, and then you define views that are partial aspects of this model that you can project. So my question here is, does your approach support this scenario as well, where you have, let's say, a very big model, and then you only extract partial views from it?
Yes, so actually, EMF views, the insight, I didn't give all the details of the insights of EMF views, but there is a core language inside that has different base operation, and one of these operations is actually a filter operation. So what you can do is that you, from a set of models, you can actually, or one model, you can actually filter elements from this model and keep only the models that you think are relevant in the view. So this is something that is possible. I didn't show it here because actually the purpose of this work was to show the combination of different kinds of resources all together in one single view. But you can do the opposite. You can have one single model, possibly very large, and then you can filter elements to show only parts, to show only relevant parts of the original model. So this is something that is possible to do with.
Yeah, of course, the scenario you have presented here is much more challenging because you start from heterogeneous sources. So another question would be how easy is to extend this to other sources. so that I can get information, let's say, from Excel files or from XML files.
So
Easy
there are
or
different ways of extending. So either you provide extension by plugging another modeling technology, and in this sense you can benefit from the persistence layers that are provided by the modeling technology. And this is actually what we did with Epsilon. Initially, EMF views, as of course, was built only on top of VMF, and the fact that we integrated the use of Epsilon allowed us to benefit from all the connectors that come with Epsilon. So the CSV connector that we use here is one example of this. So this is one way of extending the framework. The other way is to work directly by adding a new specific connector. So this is what we did with the integration of the NeoEMF specific connector. So here you can add a specific backend and make it compatible with the view framework. So these are the two ways to extend. Either you add a new modeling technology and you get for free with it all the different underlying connectors, or you directly add a specific connector to EMF or to Epsilon now that we support it as well. But still, there is a cost to do that, of course, because you need to implement the compatibility layer between both of them.
Good. And what is, if I may ask, because you mentioned that the project that where you built all this finished. So are the plans for extending this, or what will be the status of this work? Because I think it's very, very useful, no, for the community.
So we actually submitted some project proposal recently. So we hope that we would like to be able to pursue this. So I mentioned at the end a couple of possibilities of extension. So there are many things that we would like to do. So for instance, we would like to work on the view update to improve the view synchronization. So in both directions, both update and maintenance. And we hope to be able to do this in the context of a project, a European project that we submitted. So we're still waiting for the answer. But yes, I hope at least to be able to continue to work on that, and we are currently looking for resources to do that.
Good. Any other comment you would like to make to Hugo? All right, we still have a slot at the end where we can have extra discussions. Thanks a lot, Hugo. Thanks a lot for your presentation. And let's move to the final presentation by Eugene Siriani from the University of Montreal. And the talk will be about collaborative modeling with AtomPL. Good.
Yeah, so I hope it's all working. Great. So thanks for having me. This is a great workshop, a great opportunity, a great project you are having, and it's very closely related to some of the research we have been doing in my lab at the University of Montreal. So I will probably go a bit quickly on the introduction part, because if you are here, you probably are quite motivated by the fact that collaborative modeling is important. So I will very quickly just say that why do we collaborate? Well, simply because today any significant software or system is built in teams and not an individual. That brings along the different team members bring along different expertise. Just think about an agile team, for example. And because we are used to working at a distance, not everybody is at the same place at the same time, especially during this 2020 year, we have seen the proof of that. So the collaborative software development usually require different expertise from different domains. I think of an energy efficient tool, an energy efficient building management, where you need different domains from architecture, material science, environmental science, software engineering, urban planning. That they must work in a coordinated manner. So we need to have communication, consistency between the different artifacts built, and a uniform interpretation of how the system is perceived. And they each work, you can have also sub-teams, not only individuals, but work on different aspects of the system. For example, the energy-aware development, the occupation, the maintenance, the demolition, etc. So collaboration situations. So these teams of stakeholders work together to produce a coherent and complete system. So typically there are three situations when individuals within or across teams collaborate. Is if they work on the same part of the same artifact, if they work on different parts of the same artifact, or if they work on distinct artifacts but that are part of the whole system. So very quickly, working exactly on the same artifact, this is equivalent to having an active screen sharing collaboration. I would say a la Google Doc, right? Where you can see all the changes are reflected by anyone, are reflected and perceived by everybody. We can work on different parts of the same artifacts. So in this case, we assume that the artifacts, for example, the models can be partitioned into maybe submodels or views. But of course, for that, we need mechanisms at the language level to be able to split the artifacts. And the third situation I mentioned is where each artifact represents a concern of the overall system. And we basically build the complete underlying model and underlying system is built by the union of these different concerns. So this is quite related to what Juan was asking in the previous talk. So this brings us to something called multi-view systems, right? As we have seen in the previous talk as well. So these views are useful to customize how the model is perceived. So with the views, we can decide what kind of information we want to show to the specific target user of that view. For example, we can show an aggregation of some of the information of the raw model. We can also decide to represent differently. For example, think of concrete syntax. Maybe one wants to see it in a tabular format, and the other one wants to see it in a graphical format, for example. It also it is useful to decompose a model into views, because this will reduce the conflict rate. So why do we have conflict rates? Well, because imagine you have concurrency and you have multiple people working on the same model but from different views. Well, if they're working each one on their own views, it is less likely that they will intersect. And that one operation from one user may conflict with an operation that the other user did. It may happen, of course, but it reduces that rate. And finally, it's more from a security and access control point of view. Well, it's a way to also protect your model, so you can have different views with different access rights. For example, one can only read this part of the model, but can write this other part of the model in his view. Think of access rights in views with traditional database systems. So it gives you finer granularity. So let me, I will not formally define what a view is. There's ample literature on that, but I will just very quickly say how we are taking view, what we're considering as a view in the context of this talk and the work we've been doing. So here we consider that a view is a projection of the properties of a model, meaning that it projects some of the information which may also be interpreted information. For example, aggregation, we can have the average or the sum of some values, for example. The view can be a proper subset of the model also. So it can be literally the model expressed in the same language, but showing only a subset of the components it has. Or it can be some kind of abstraction of the model by aggregating some of its properties. In this case, the view and the model are expressed in different languages, but they may also be expressed in the same language, but maybe offer different presentations, so different concrete syntax. So when you're engineering a view, when you're creating a view, how do you look at it from a language engineering point of view? If you're used to building domain-specific modeling languages, well, this is maybe for you. So in here, we consider a view as a model as well on its own. Okay, so it has an abstract syntax, a concrete syntax. It has its proper semantics that is given by the mapping to the model. And so the view conforms to its own language, but its language is kind of derived. It's basically a set of mappings, right? So it has the language of the view is basically needs the elements. So what kind of elements will be present in the view, and the mapping of these elements is defined by the abstract syntax mapping from the model to the view, so that we can have a projection of the elements of the underlying model to the view. And similarly, the concrete syntax mapping assigns a proper concrete syntax to the elements of the view here. Okay, so the abstract syntax mapping is specific to one view, and the concrete syntax mapping is also specific to one view. However, the concrete syntax mapping in general, is not necessarily shared across different views. Of course, we must refer to at least one element from the model, but in the view, you can have elements that were not in the model. For example, if you're having an abstraction. And as I said, it has its own concrete syntax. So some underlying assumptions that may seem strong, but are necessary for the work I'm presenting. So the models, we assume the models are stored in a repository, therefore can be shared. Okay, so when I say the word model, it includes also the views, right? Models can only be accessed via their views. So this means that whenever I want to create, the first time I want to create the model, the first element I want to put in the model, I actually have to go through a view. So by default, there's a view. There's like a first view where I create my model, and then from that I can spin off other views, and then they create other elements that may or may not be part of the initial view. But at least there is one view for each model. And a corollary of that is that every element of a model exists in at least one view, so that the union of all the elements of the view, right? So the union of all EVIs is equal to EM, right? The set of all the elements of the model. So this means that the underlying model is composed by all the elements of the different views. Okay, so that's for the definitions and the background. So the first thing I want to talk about is some work we have done about multi-view modeling scenarios. So it's very much from a use case point of view. And we identified 4 typical multi-view modeling scenarios. So previously I mentioned there were 3 collaboration scenarios. So they are here, but with multi-view, there's one that is extracted a bit more. So the first one is when 2 users are working exactly on the same view, simultaneously projecting a model, part of a model. The second one is when we have 2 users working on different views, but of exactly the same model. The third one is when we have 2 users each working on a view of distinct models, but there's some kind of link, some kind of consistency link between the 2 models. And the fourth one is when you have one user working on a view that projects two different models, while another user is working on a view of one of the models, for example. So let's go a bit more in the details and the challenges that each of these scenarios raises. So in the multi-user single view model, the users are working exactly on the same view, therefore they see exactly the same information in the same language. So typically we use the same concrete syntax between the two, because it's exactly the same view, therefore they are using the exact same concrete syntax. So this is similar to active screen sharing, right? So any change done by user 1 are reflected by user 2. And I will, for each of these scenarios, I will talk about what happens if you have concurrent changes that are conflicting at the same time. So typically in a multi-user single view scenario, this is done this is resolved in a first in, first out fashion. So the first one, the first operation that arrives, it happens, and then followed by the second operation. And if the second operation is not allowed, then it is not allowed. The second one is a multi-view single model scenario where each user is working on a different view of the same model. So as I said before, they share the same. They can be presenting the same elements or not. So there may be an intersection between the two views or not. So in the case where for the elements, if one element of a view is changed, but it is not part of the elements of the other view, then the changes are not reflected. But if it is shared, then the changes can be reflected. However, note that here we're talking about the abstract syntax changes. What about the concrete syntax changes? Well, in this case, because each view, V1 and V2, have their own concrete syntax, therefore, if I, let's say, I don't know, I make it bigger, and if I resize an element, and resizing does not change anything in the abstract syntax, so it doesn't have semantic meaning, it's just visual, then that change will not be reflected in the other view. And what happens if you have simultaneous conflict changes? Of course, this only happens if in the shared space of the elements. So there, a conflict management strategy must be put in place, because we have to make sure that the views are consistent with each other. There are different strategies of resolving these conflicts. I will not go through them completely. I will talk about some of them, how we did it in the tool Atom PM, which is the second part of the talk. For the third scenario, the multi-view, multi-model. So in this case, we have users working on different views, and each view is a projection of a different model, but the two models have some kind of dependency that can be expressed in different ways. For example, they can be subject to global consistency constraints. We can have an explicit link, an explicit reference from one element or from one of the models to the other. This reference may also be bidirectional, so that's another case also. Here in this example that I'm giving here, we explicitly have that the M1 has a reference to M2 has a reference to M1, and so E prime can act, for example, as a surrogate or as a proxy of E. There's also another way you can also have this link between the elements by having an explicit model that links, that makes the mapping between the two models. Okay, so you would have an M3 model in this case. So in the case of references, okay, whether they are using an external model or references directly, the reference can be active or passive. So active means that this proxy also allows to perform operation on it, and if it's passive, then it's only a read-only operations that can be applied, and only changes applied on the original or on the source of the reference get propagated to the target. So of course, maybe not all the changes of the source of the element need to be propagated to the other model, or at least to the other view. Maybe it is propagated to the other model, but may not be reflected to the view. And so we need to decide, how, the mechanism of how this change propagation happens. For example, if I delete this element, should it be also deleted here and therefore deleted from the view, or should I leave it there as a read-only, maybe marked as it has been deleted? You can ask whether it must be approved, and so. So that change propagation needs to be mitigated. And about the conflicting changes, so if I, for example, in the active, this can only happen in the active scenario, so active reference scenario. So if here user one makes a modification in his view on E, let's say it changes the value to 1, from 0 to 1, and the user 2 in the second view of the other model that has a reference here to that element changes the value to 0, let's say, then we have a conflict, right? Which one should be resolved? How do we resolve this conflict? And that happens, exactly at that situation. And these kind of conflicts can be resolved in the same way that was done in scenario 2. And the fourth scenario is the single view multi-model. So it's in the case where I have one view here, V2, that is projecting 2 models, and I have someone else working on one of the models, let's say. So in this case, V2 is an abstraction of M1 and M2, right? So we can actually go back to this situation and consider that it's like having an M3 model that refers to these 2 models, and then I have a view on that one, right? So it's kind of equivalent. And since we consider views as models as well, so basically it is solved usually similar to the previous case, but the dependency is defined at the view level, not at the model level per se. And in this case, we usually have an active reference variant, because any change that happens here or here will be reflected in the view. And so the same kind of concurrency control systems should be applied. So this gives an overview of the different multi-view collaboration scenario possible in the context of a modeling environment. And there are other orthogonal dimensions that we may be wanting to look at. For example, the mode of collaboration. For example, if it's a real-time collaboration or near real-time collaboration, where yes, I have different views, but each one is working on his view at the exact same time. So in this case, usually the different architectures rely on an MVC architecture, where the model changes are propagated almost instantly to the views of interest, and the conflicts have to be resolved as they happen, right? So the users subscribe to a view subscribes to basically defines a projection of the model, and that's how multiple users can see can interact with the some situations where you can, some strategies that some tools, for example, OBO Designer, have opted for to control or to handle the conflict management, concurrent conflict management, is, for example, through locking. But as we will see, there are other ways of resolving this issue. And the other mode of collaboration is, of course, the offline mode. So in this case, we have multiple views, but we're not necessarily working at the same time on our views. And usually this follows a decentralized architecture. For example, following a Git, like a WebGME uses that. And we have domain-specific or view-specific version control system that allow you to synchronize and commit and basically merge the different changes. So in this case, the views refer to a proxy model, okay, that is usually, for example, local to the session while you're working on the view. And when you decide to commit, right, or to save or to push, then that's propagated to the central model. And so the conflicts only happen when you actually push there. So you can resolve conflicts locally, and then what they claim, especially what the WebGME claim with their experiences, is that having this two-phase, let's say, concurrency management system reduces the conflict rates when it goes online, when it's pushed to the online model. So this is one dimension, okay, that we can look at for a multi-view modeling. So there are many other dimensions to look at. So in this feature model that was presented a couple of years ago, so we enumerated, some of the requirements for collaborative modeling. And so the first one here is the collaboration scenarios. So these multi-view, multi-user supports that I just described here. With respect to concurrency, so here I opened up just a bit more. So as I said, it's possible to use locking. It's possible to be, to decide whether we're real time or offline. It's also, so another dimension is the versioning. So yes, you can have a version control system even when you're in real time. What happens, how do you deal with history of past operations, and do you allow batch operations or atomic operations only, and how do you resolve the conflict between them? So basically, is it a transactional system, an atomic system, or not? Then there's the data storage. So how is the data stored? The previous talk has mentioned a couple of ways that it's possible to persist the models, and so this falls very well in that framework. There's the network architecture. So what kind of underlying protocols are used to communicate between the different peers or the different clients and the server, etc. How are conflicts managed depending on which level of granularity I want at the view level. For multi-user, so here I expanded also multi-user. So do you need to know who is performing what action? Do you want to control the access of per view or per element, for example? Do you want to know that other people are working at the same time on your view or on elements or on another view that shares elements with your view? And then there are, I always like to talk about undo, redo, and copy paste, because this is just a completely different way of thinking, right? We have to change the paradigm of undo, redo, and copy paste, because it, what does it mean when I undo something on my view? Should it undo it locally for me, or should it also undo it for all the others? Is it something on my view? Is it something propagated to the model? Is it something that must be reflected to the others? Because imagine if I perform an operation and someone else performs an operation, I expect that my undo undoes what I have done and not what the other person has done. So this brings to interesting research challenges there. Same thing for copy pasting. Yeah, so I'm not gonna go exhaustively into all that, but yeah, so there's different dimensions, different aspects we have to think of when we're talking about multi-view collaborative modeling. And thankfully, there are some tools that support some of these features. And so here, this by no means is a extensive or exhaustive list. And you have seen in this workshop, in the previous talks, other tools as well that fit, that could go here as well. So I just want to talk about some, maybe older tools. For example, like Design Space is an Eclipse-based tool where it's a round robin, so users take turn. So first it's this person, he can work on it, and then when he finishes, then it's the next person, and when he finishes, then it's the next person. So you kind of don't have this, by construction, you don't have these conflicts that happen directly. In Ptolemy, at least the second version of Ptolemy, you can design and execute heterogeneous modeling languages. So the collaboration is done at the language level, but they don't have multi-user support, but they can have multi-language support, and therefore, by extension, multi-view support, but still with a single user. And then you have all the all the online Eclipse spin-offs, like Eclipse Che. So it's basically, I would consider it a bit like active screen sharing there. Gmod Studio, a bit like Ptolemy, allows you to compose multiple DSLs into a cohesive system, but you can't have concurrent users working on it. WebGME is a collaborative version of the older GME tool, where you can share and work on the same model. It's based on a branching scheme like Git to manage concurrent actions. So I mentioned it briefly before. Obeo Designer allows for multi-view and multi-user support. But they enforce locking, and they have made some interesting choices in the locking. So for example, you can decide to lock the concrete syntax, or you can decide to lock the whole model, the whole view, the single elements. So this is more a locking system. And the last one here is AtomPM, which I will talk about in this second part of the talk. So AtomPM is a modeling language workbench that allows you to develop DSLs and model and edit models and manipulate model and run transformation, run simulations, execute your models, all on the web. And it is very concrete syntax driven. So everything you do has to go through the concrete syntax. You do not manipulate the abstract syntax directly. And AtomPM is solely dedicated to graphical concrete syntax style. Yeah, so here are some words on it, some introductory work on it. So it's you have to recall that if you decide to use AtomPM, remember that it's a research framework. It's not a full-fledged commercial tool. So beware that it may have some non-user friendly decisions that have been made there by the accumulation of the different students and researchers that have been working on it. it's open source to framework to design domain-specific editors, execute transformations, and manipulating and managing your models completely in a web browser. So you don't need any installation unless you want to install the server. Of course, you don't need any installation, and it's completely independent from any platform. And it follows the multi-paradigm modeling philosophy, where there we consider everything to be modeled. So as I said, views are considered as models, even toolbars are considered as models. And so you can have when we talk about multi-level of abstraction, well, you can decide to have it's not a strict 4 meta level hierarchy where you have M0, M1, M2, M3, but you can have as many M3s as you want. So we typically see it as MI, MI minus 1, MI plus 1, so that we can have different levels of abstraction and different formalisms and processes to use each DSL. The tool is completely bootstrapped, so it's completely modeled by itself, which may explain some of the maybe not so user-friendly interactions that it imposes. So I'll talk a bit about the architecture of AtomPM with respect to the collaborative part, and how we have implemented this multi-view modeling support of the different scenarios I explained before in AtomPM. So it's a 4-tier architecture, your traditional way of performing cloud-based softwares. So you have a client that is thin, where basically it's just the web browser of the client, and then you have the server. In our case, we rely on a Node.js server that encodes, all the communication between the client and the server, and in it, we have a layer before the persistence layer. We have the model view controller layer, but here you will see it's not the MVC architecture that you're used to. We will talk about it here, because model in the MDE way, view in the multi-view way, and controller, which controls the communication between them. And on the rear end, we have the Modelverse, which is basically the modeling repository, which is not necessarily, you shouldn't think about it as a persistence format, but more as a repository, an online repository of all possible models. Basically, that's the philosophy behind it. So very quickly, each of these components. So the client, as I said, is a very thin client, so there's nothing to install. All the models are saved on the cloud, and it's all you need is an SVG compliant web browser, because we use HTML5 and SVG there. It allows you to only model graphically. So all the operations, whether you want to create elements, modify their values, delete them, or read the properties of some of the elements, are done through interactive mouse clicking, basically, or shortcuts on your keyboard. And it comes with different tools and a complete plugin infrastructure. And so each DSL is basically like a plugin that you add, and you can add custom tools to perform customized actions. And one of these tools is basically a bulk operation. So you can have this toolbar here, and for example, instead of repetitively creating 5 times the same element, you can just say times 5, and it will create 5 times, for example. We also have different mechanisms. We have complete workflows that are implemented that you can just that will just automate some processes, and you can customize your workflows as you want. So there's many tools, and they're all completely modeled within the tool. On the web server part, so we've chosen a Node.js using a 0MQ messaging system. So if you know a bit about 0MQ, we use the couple of the protocols like the pub/sub, and I don't remember the other protocol that they have, which are actually quite efficient for communication, and it's compatible with many different programming languages. So it allows for multi-tenancy and multi-user support through socket IO. We also have what we call the AtomPM messaging service. So it is quite nice to think of all the possible ways of resolving conflicts, you know, when we have simultaneous changes that happen at the same time. But you know, some of the time you just can't resolve it automatically, or you know, if one person resolves the conflict, then it may not please the other person who also is part of that conflict. So this is where we have a chat service where they can just communicate with each other and decide, you know, how to resolve it. And we found that this way is quite useful in practice. Yeah, the third part, I'm not really going to talk about it, is just that you know, the execution engines behind are all modeled by a series of state charts communicating with each other, but I'm not going to go into that in this talk. The model view controller component. So as we can see in this figure, so for each model there is a controller, and you can have views subscribing to a controller, therefore to a model. And we have different levels of granularity of controllers. So you have a model controller that so for example here the red one is responsible for model specific requests, for example changing a value, adding an element, etc. You have the package controller that is responsible to non-model specific requests. So for example, they can you know, save or open or load or add a model, or, you know, all the other operations that are not specifically modifying the model itself. The node controller is there to do the load balancing between the controller in the node, so that if you have, you know, I don't know, hundreds of users at the same time, there's some load balancing being done. And finally, the super controller is just a dispatcher of the messages to the right controller, depending on where it comes from, where it received the request from a socket. So the controllers do not process the operations when the model controllers do not process the operations directly. So if I send a request to add an element, the controller is simply passing that request to the Modelverse kernel that acts as an API of the Modelverse. So it coordinates all the operations and ensures consistency and conformance. Currently, we have only one point of entry to the Modelverse, so that's a bit the part where we need to work more to improve the performance, which is not bad. I will show you later. So the MVK receives the requests from the controllers and performs the model operations. For example, any CRUD operation, conformance checking, execution. So we also have an action language that is modeled in the Modelverse, so that you can execute it directly. And finally, the last component is the Modelverse. So it's a standalone repository and considers everything as a model. So including meta models, concrete syntax definitions, models, views, transformation tools. You know, everything is considered as a model. And we have a physical representation that is that can be different flavors. So depending on which version of AtomPM you install, it may be JSON or it may be a textual syntax, but that is saved just for. So you should imagine that the Modelverse is like an operating system, right? It's just always on, and the serialization is only meant for fault tolerance point of view. So in the Modelverse, how do you integrate? Because one of the scenarios we mentioned, the one where you have multiple models with multi-view multi-models, or even single view multi-models, well, we need a mechanism, an internal mechanism at the repository level to be able to compose these models together, or to link these models together. So every model has its own, every model element has its own namespace location, and that's how you can make an explicit reference to that location. And that's how you know, I was talking about the active and the passive reference, so that's a property of the reference you can make there. So you can completely, you know, you can integrate and compose languages, models, you know, whatever you have in whatever artifact you have in your model repository inside as a completely this way. But from a graphical user interface point of view, we only have a restricted version of that. So the multi-view modeling support in Atom PM. So we do support multi-user single view. So that's the first version, the first one that I mentioned. So you can just click on screen share, and it will just give you a link, so you can actively work on the exactly the same model and the same view. Multi-view single model is supported with the model share feature. So you can work on different views of the same model, just the same way. And the multi-view, multi-model, and single view multi-model are supported in the backend, but are not supported in the front end yet. So just a small word before I conclude on the performance. So we've run some controlled, you know, lab environment, lab experiments inside a controlled environment, where we tested, you know, different dimensions, you know, adding different users, increasing the number of views, increasing the size of the model, etc. And what we have seen is that the size of the model doesn't really influence. So as you see here, the size of the model doesn't really influence the performance. But what happens is that the more users you add, the more variance there is. Okay, so that's basically what we have. And also we see that multi-user single view performs better overall than multi-view single model, and which in turn performs better than multi-view multi-model, which is kind of to be expected. But in general, and you can see here, we did tests up to 200 concurrent requests. You can imagine that in reality, you will probably be within, between 1 and well, not 1, but within 1 and 50. So looking at 50, the times are quite appropriate for the response time and the request duration from the ping to the pong back, basically. So to conclude, I have talked about multi-view support in this talk, but there are other dimensions that I think are necessary requirements for collaborative modeling, but not necessarily sufficient. And that is really looking for, one of the dimensions here is looking at the user perspective. So in this talk, we looked at the view perspective, but what about the user perspective? So supporting multiple user kind of requires you to have a version control system there. And frankly, today, there's no software built without version control systems. So we need to think about version control systems that are adaptable to views, right? Not necessarily using Git or SVN just as is for the repository of your models, but port it to the end user, right? So that he understands in a domain specific way, in a semantic way, what is a difference, what is a merge, etc. And also the other point of multi-user is to adapt the editors and the environment, the modeling editors to the user. So today we most of the tools, we use most of the language workbenches, whether it's Atom PM, Eclipse, WebGME, all of these. When we generate the domain-specific editor, it's for the end user, right? But who built the editor? It's probably a software engineer or a language engineer or something like that. And the generated editor is exactly, you know, so when we generate an editor in Atom PM, well, it is in Atom PM. When we generate an editor for Eclipse, it's in Eclipse. And therefore you impose the same way the user has to interact, whether he's a language engineer or whether he's a domain expert, he has to interact with the tool in the same way. And that kind of contradicts the philosophy of domain specificity. So we have to make sure that we really, when we say we generate a domain specific modeling environment, that it's really domain specific. And it's not just the text that I can write or the icons that I can draw, but it's also the interaction, the feeling, the semantics, the overall layout, etc. I'll talk more quickly about the other two because I'm probably running out of time. So the multi-paradigm support. So of course, when we're, as we said in the introduction of this talk, it's necessary to when we have multiple teams working together, they are not necessarily using the same language. They're not using, they don't have the same expertise. And so they may also be using different paradigms. And so we need good support to have to enable multiple DSLs, but also composition of heterogeneous languages. And some of the tools I mentioned focus solely on that, and it would be good to also extend it to this multi-view and multi-user approach. And finally, we also have to think about not only the design phase, but also the runtime phase. You know, what happens with the models? You know, when I've created the model, okay, it's not an end, right? It's a mean to an end. So am I going to generate code? Am I going to run simulations? Going to run analysis? Going to do debugging? And so it brings us to how do we do this kind of execution, this runtime, when we have multiple views, when we have heterogeneous models as well? Okay, so these were basically points of discussion, maybe that may spark some discussions for the session. And so thank you very much, and I'll be happy to take questions if you have some.
Thank you, Ian, for the very interesting presentation. Is there any question you would like to ask Eugene? Right, I can warm up with one question. So yeah, you made a very comprehensive introduction to all possibilities in collaboration with conflicts, with the different views, and so on. But then you also saw performance measure with up to a lot of users, no, more than 50. But I wonder, if you have so many users, you will probably have a lot of conflicts, no? People moving things around, and do you support some kind of protocol or some kind of role mechanism that can somehow organize a team of engineers working on the same view at the same time?
Yeah, so I was, thanks for asking this question, because I was thinking of adding, you know, something about that in the slides, but for time I didn't do it. So yes, this is something that we have run into, and you know, when you have an extreme, you know, we can consider that 200 concurrent users is an extreme case. You will have a lot of conflicts, and therefore it's not possible to ask them to, you know, resolve the conflicts themselves each time. You know, it's 200. If you know, if you do the Cartesian product, then you're exponentially augmenting the number of possible conflicts. So they will be spending more time, you know, resolving conflicts and merging than actually doing the work that they need to do. So we've been recently working. I have a master's student who graduated a year ago, and now we have a postdoc taking the lead on that project, is looking at real-time, you know, how, for the real-time part, not for the offline part, for the real-time part, how do you manage concurrent users? And actually, we rely on a protocol called CRDT, so conflict-free data structures. So basically, they are data structures where you encapsulate your models and your elements inside the data structure that, by definition, by construction, will resolve conflicts automatically. So I can you know, probably not say too much about it, but there's a lot of work that happens on that in the parallel and distributed system community that try to resolve that, and so we're relying on that part.
Mm-hmm. Yeah, looks very good. I think we have a question in the YouTube chat by Mohammad Reza Sarbab. So, very sorry for the pronunciation. The question is, how does AtomPM work for semantic conflicts and conflicts that depend on the modeling language?
Yep. Yeah. So so if you're asking how does AtomPM resolve that, I will tell you it doesn't resolve that. It does it really at the syntactic level, at the abstract syntax level. But however, we have been working on lifting a bit the conflicts to a semantical level. So we look at for example, with Juan, we've been collaborating on some work on domain specific and semantical version control systems, where we ask the language engineer to provide semantic rules to define how conflicts can happen and how they are resolved, but from a semantical point of view. So I can refer to you. So there's one paper at the SLE 2019 about that for the differencing, and we're currently working on the merging part as well.
Mm-hmm. In the meantime, while people warm up for additional questions, I have the question that I'm not sure if you treat differently the conflicts that may happen at the concrete syntax level only, where one person moves something in one way and the other moves into another, and the conflicts that are really semantical, right? So I guess they are treated differently. Or do you care at all about the conflicts in the concrete syntax alone?
Yeah. So it depends on the mode you are in. Actually, I'm not sure if I can do that, but I had prepared here. If I do this, probably you will see it. Here I have done a screen share. So where I share both we're working exactly on the same view. And so, for example, I can decide to change. I did the model share, so I can decide to have my own representation here. So it's exactly the same model, but with different concrete syntax in that sense. So if I create an element here and I move it around, it will be completely there. So it depends on the different on the different mode you are in. So if you're in screen sharing, model sharing, so multi-view, multi-model, etc. So depending on which option you have chosen. So for example, if I disconnected from here, then in this case, if I even, if I increase its scale, it will also increase it on the other side. But if I did a multi-view, multi-model, then scaling does not affect the semantics or the abstract syntax, and therefore won't be shown there.
Right. I think we have a question by Jan Conlane. Jan, would you like to ask it, or shall I read it?
Yeah, I can ask it myself. Maybe it's a bit complicated. So from my experience, when you're modeling, you're not after all these micro tasks where you do the conflict resolution, but you're doing a bigger task that consists of many changes. Like, in traditional software development, you elaborate a complete commit for Git, or even a series of commit that actually perform a certain task. Do you perform any conflict resolution on that coarser level? Because when you do, when you do this micro conflict resolution, of course, you do not run into the coarser issues, but you may end up with a completely inconsistent system because all the combined changes don't make sense together.
Yeah, absolutely, absolutely, and that's a good point you make. And currently, we only do the atomic changes, but the coarser changes are actually quite useful, especially when we want to look at semantic modifications, right? So you have these fine granular modifications, maybe 3 adds and 1 delete of these specific 3 adds and 1 specific delete means, I don't know, means something in a domain specific sense, but it's one action as a coarser level. So you can look at it as a atomic transaction where you either perform all these smaller actions or you perform none of them. And so you encapsulate them in what I call a transactional operation. But there are different ways of looking at that. And you can also try to see if you have multiple conflicting coarse grain operations that may be sharing the same operations, or maybe one is contradicting the other one. You may optimize also the operations to do, because maybe they're, the first 2 adds are the same, but the 3rd add and the delete are different, for example. So you only need to perform one of them. So there's all these things we can think of, but no, we don't support that for now.
All right, and I have another question, and that is, how do you deal with changes in one view that are invalid in the other view? So, for example, a dangling edge in a diagram. So you create a new connection in a tree, but you create the connection first, then connect the source. But at the same time, if you look at the diagram model, you have a dangling edge. How do you deal with these kinds of things?
Yeah. So the specific question you asked is one special case, because actually, as I mentioned a bit before, there are 3 cases we see. One is there's a constraint over the views or over the models. One, there is some kind of physical link, right? Like a reference or something like that. And the third one is you have an explicit mapping that defines the consistency between them. So another model that defines the consistency between the 2 models. And so in your case, it may be, for example, in the reference, right? When we have an explicit reference and you delete one element, what happens if there are elements connected to it, but they're not in the same view where you deleted it, they're in another view. So, and that's what I mentioned about the cascading, the changes. And in our case now, what if something like that happens, then it will be kind of highlighted, and the chat will automatically open between the 2 people in the 2 different views. So they have to resolve it, because we can't decide, because it has too much side effect.
You have a chat integrated.
Yeah.
Oh, that's a good idea to resolve conflicts on the human level.
There's no way.
Right. So maybe I would like to have the final minutes with questions that are for all speakers or even for the audience, to have some kind of more general discussion. Because Sergin, for example, have been presenting all these very nice collaboration features, but then in the morning we have talked about the language server protocol and the graphical language server protocol. So does it influence in any way the fact that you have collaboration? So does this impact in the language server protocol, or it has no impact? So that would be my question. So maybe for Jan, maybe you have mentioned this morning the.
Yeah, this is one of the reasons why I put so much stress on having an authoritative model. And so one representation of the model, which is the ultimate truth, and everything else is derived from that. If that's text, as in my case, for the language server protocol, you can use the concurrent editing of the text in order to have collaboration. And that's already there in VS Code. There's live share, and we're building something similar maybe in the future for Thea and Gitpod. So on that level, it will be pretty easy. On the graphical level, I'm, at least from the technologies that I'm after, I'm very skeptical that it's ever going to work out, because it was already very complicated to sync a diagram view on text, because they behave so different in terms of errors and syntax errors or validation errors and stuff like that, that it usually doesn't make sense to edit both at the same time, even for a single user. So that's my 2 cents on that.
Massimo has a question.
Yes, I have a question still for Jan, following up on this. So your text-first approach is very interesting. But then also we saw different approaches throughout the day, for instance, in AMF Cloud with synchronization by model server. So do you believe that text-first is the best approach in any situation, or do you envision some cases in which you don't want to do that?
Yeah, so I think what Typefox and was always also after was a pragmatic solution with little effort. And in that, I guess this text solution, especially Xtext, really made a dent in the universe. So that is really incredibly efficient to get your language implemented in short time. But of course, it's text, and it's very developer centric. So as long as your users have no problem to deal with Git or an IDE, I would always go for the text-first approach, because it integrates with all tools you already have. It integrates with other languages that you already have. You can just use it in the same IDE. It's not a separate tool. You don't have need any additional databases, conflict resolution tools, and so on. So in that case, that your users are actually developers or people who are used to using IDEs, I would always go for text.
Yeah, thank you. But I just elaborate a bit. Even in the case in which users are not unfamiliar with text, I'm wondering if reasoning in a text-based way poses some constraints to the graphical editor, like, for instance, to the kind of operations that you want to add to the graphical editor, because you start asking yourself, well, does this operation make sense in the language server protocol as a text-based operation? Does this influence the graphical editor some way?
Okay. Yeah, I guess what I've shown in my demo was reconnecting stuff, so or drawing a new connection, and that is definitely something that you cannot do with a language server command. So what you have to do is you have to create your own commands that encapsulate that action and execute them on the language server. So this is beyond doing a refactoring or beyond doing asking for content assist at a certain place. So it's basically about packaging user interaction into a command and then executing that where you have the model, and that's on the language server. So it's pretty powerful. I'm not sure about the constraints, in which cases this was gonna fail. I can't. Yeah, I mean, it's very generic. So,
okay,
but it's then beyond language server protocol.
Okay, great. Thank you.
All right. I would have another question. If for GenMy model, right? Because we also saw in that presentation, I think don't remember if Matthew or Blaso were mentioning collaboration, right? And they were mentioning synchronous and asynchronous. So is it the kind of collaboration scenarios that Eugene was presenting, where you have multiple users that can work together? What is it? Something similar what you have in my model, or?
I suppose that I leave the question to Matthew because he was the one that was presenting about the synchronous and asynchronous collaboration. If he's still here, I mean. I suppose that he's not. All right. Well, currently we have a synchronous collaboration. It's like when you're editing, for example, a Google document. And we are doing this because the hypothesis behind it is that on server side, the requests are always ordered. For example, let's say that you have two users, A and B, and that both of them are trying to make a modification. We suppose, I mean, the hypothesis is that at the API side or on the server side, the requests are always ordered, and so we always know which one of the users is sending the request first. So we are doing that modification, and then we are doing the modification of the second users. And this is basically like when you're editing a Google document. We're currently working on offline mode, and I suppose that this is what Matthew was referring as asynchronous collaboration. And the idea behind it is to be able, for example, to continue modeling, let's say, when you're taking the plane. But there are a lot of problems about after I mean, when the user finishes with the offline mode and when he tries to synchronize the model with the current version. And this is why Matthew was talking about EMF compare. I mean, being able to compare the new version with the old version of the model, see what has changed, and then accept some of this modification, or for example, refuse some other modifications. Right.
Mm-hmm. All right. By the way, I think Felicien has another question. Would you like to read it, Felicien, or shall I do it?
Yes, you can read it.
All right. So to any speaker, probably to anyone listening, what general learning recommendation would you give to someone who wants to start thinking on how to migrate his approach to implementing a cloud-based DSL? Anyone want to take this one? Well, yeah, probably my recommendation would be to have a look at the presentations that we have seen during the day, and try some of the tools. Actually, there are some other possibilities that have also been mentioned but not really presented. No, like I think Massimo mentioned yesterday, Sirius on the web, or so, which I think is already available, and today WebGNE have been also mentioned. So there are plenty of tools. So probably, I guess this would depend on the kind of DSL, whether your DSL is very big, or if it is a DSL based on, let's say, UML stereotypes. I think GenMy model was able to support that. So I guess it would depend, and also on the kind of concrete syntax that you envision for your DSL. All right. Any other comment or suggestion we would like to discuss? Well, if not, thanks a lot to all the speakers. I really enjoyed all the presentations. I think they were extremely interesting. not only for me, I guess, but for everyone, to all ESRs. I think all presentations were really touching on many relevant things for the ESR projects, and I'm very sure that they will profit from all this knowledge. So thanks again to the speakers. If you want to send us your slides, we will be happy to put them on the website. And what I'm not sure is what will happen with the video in YouTube. Not sure if we can sort of link to the recording, because that would be, I think, very useful. And yeah, we'll try to do that. I think that would be very interesting for us, so that we can see again the presentations.
Yeah, sure. We have planned to put the video in our channel.
Yeah, that would be great. Yes.
Yeah.
And yeah, so I think that would be all. Thanks to all of you, and yeah, we'll keep in contact about this. Bye.
Thank you, Juan and Sorur, for the support, the organization, and the full day chairing that is probably exhausting.
Well, it was my pleasure. So interesting.